responded. So he said it's correct. So I'm assuming that means San Luis
Okay.
Obispo.
All right. Well, good morning, everyone. Thanks for joining us this morning. My name is Naomi Newman. I'm with 3C Ren. And as you just heard, I've restarted this recording and it will be posted on 3C Ren's on-demand page, and you will also receive it in a follow-up email. Today, we have Nick Brown and Robert Fortunato with us today, and they're going to give us a guide to all electric residential buildings. And just before I turn it over to them, I have a few slides to go through. So just a reminder, please keep yourself on mute throughout the duration of the course. If you'd like to verbally participate, please raise your hand in the participants section and we'll call on you to unmute yourself. And please use the chat box throughout the course to ask questions and engage. Next slide, please. So just a few words about 3C Ren, or the Tri-County Regional Energy Network. It's a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties. And we work to improve energy efficiency in our region by offering free programs and services for building professionals and households. It's funded by ratepayer dollars, which are collected through the public goods charge found on utility bills. And the benefit of this is that there's no cost to those that we serve, and we can return those dollars back to the economy and in our local areas, which have historically missed out on some of these funds. Next slide. So we have 3 different programs at the moment. The first one is the Energy Code Connect program, which brings you this course today. It serves building professionals by offering Title 24 Part 6 and Part 11 support. And with this Energy Code Connect program, we offer the Energy Code Coach service, which is an over-the-phone, email, and in-the-field support for both residential and non-residential projects, and also trainings and support like this one, online courses, and regional forums that are designed to increase overall energy code comprehension, compliance, and enforcement. We also have the Building Performance Training Program, which serves building professionals by offering technical and soft skill trainings related to building science principles, high-performance buildings, marketing, and communication techniques. And lastly, we have the Home Energy Savings Program, which incentivizes contractors and helps residents save money and make their homes healthier with energy efficient upgrades through incentives and rebates. And with that, I will pass things over to Nick and Robert to get started in our course today.
Thanks, Naomi. And you'll be back to tie things up at the end, right? Fantastic. Hi, Robert. How are you?
Hey, Nick, I'm doing great.
Good.
Looking forward to our program today.
Yeah, and what's the best part? Broadcasting live from your heat pump water heaters?
That's a highlight, and
for
you
me too.
cooking on your induction cooktop for sure. But I think the highlight is just to bring what we've learned through, for me, it's 10 years. For you, I think it's like 8 years of living in the buildings that we designed and general contracted ourselves, and bringing what we enjoy every day to other people so that they can do the same thing for less cost and building healthier buildings, better buildings, again, at lower cost.
Well said. Couldn't have said it better. So what we plan to do today is make the benefits of all electric homes clear to you. And this is a big tent, right? There's a lot of people who can find a lot to like about all electric homes, whether it's self-sufficiency, utility bill savings, improved lifestyle, health and safety. So we'll make that clear. And then we'll cover how to do it. What systems are needed to convert your typical mixed fuel house with gas systems to all electric, including solar and battery, which are a key part of that, right, Robert?
Absolutely. Absolutely. And like you said, it appeals to so many people. I've talked to people who are, I think they're called preppers. They're ready for the demise of civilization, and they need this. And I've had clients in Malibu with 15,000 square foot homes who realize, as a result of the fires that swept through there, that they need to do the same thing. So it's all across the board.
Yeah. So here's how we have it organized. Why all electric? The technologies you need, starting with solar and batteries, really a key enabling technology. We wouldn't be here talking about all electric homes without it. And then I'm an energy modeler, so I'm going to cover what all electric homes look like in terms of energy code compliance. We'll talk about cooking part, take a quick break, and then we'll come back with water heating. And then we'll broadcast from my induction cooktop and Robert's heat pump water heaters. I'm making some brown rice today, Robert, because it takes like 40 minutes. So I think maybe this time I won't burn it. That's long enough that we might remember it's on the stove. Okay.
How long does it take?
40.
40 minutes. Holy
Yeah.
cow. You're kidding.
It's the kind of rice that's good for you. It's got
I
all
guess.
the outer shell, the husk on it or whatever.
Right. A lot of fiber, a lot of fiber.
Fiber. And then we'll cover the heat pump part, HVAC. And that's to me the easiest thing to switch along with the clothes dryer. We'll talk about overall, tie it all together, and we'll share a lot of lessons from the field because Robert and I work in this area full time and have for 10, 15 years now. So lots of stories to draw on. And like Robert said on the introduction in the waiting room, we love the feedback with you. We'd far rather ramble and answer your specific questions than talk to our slides for the whole period. So please pipe up, raise your hand, put it in chat, and we'll attend to it right away.
Yeah, and that's the advantage of having two presenters. So what's going to be happening when Nick is working on his slides and talking about those things, feel free to enter questions. So, I'll be addressing it, and when Nick's done with his slide, I can ask him the question, specifically. So we have two things running at the same time, sort of usually a running conversation in the chat, and then our conversation about the slides specifically are running at the same time. And that's, covers, it's like a twofer, and we love twofers.
That's right. Let me introduce myself first. This is my home in Long Beach that I'm coming to you from, Climate Zone 6, just like you, Naomi. It was a almost original 1950s ranch house when we bought it, and we did a deep energy retrofit on it. High performance walls, high performance attic, high performance gas and electric systems. Because back then the energy code told us, focus on efficiency. Electric, gas, 6 of one, half dozen of the other. There are two ways to get at the same thing. And I was a little myopic in that. Robert, when he did his remodel, as he'll tell you, he did it all electric. And I chose mixed fuel. And that was a mistake in retrospect. I didn't understand the key differences in health, safety, and greenhouse gas emissions that electric homes have a clear advantage on. I do now, and I've since retrofitted the main house to be all electric. I also added an all electric ADU above the garage, which you can see here. So you can see I learned from my mistakes, and that's rented to a lovely couple in their 30s. They love it up there. They've been there a couple of years now, and it's net zero carbon. So we're going to explain to you over the course of today why that old target of zero net energy isn't the perfect target to be working towards today, and we'll make the case that zero net carbon is. On the right is my kitchen in the main house. And here's the great room in the ADU with a ductless mini split, an induction cooktop, heat pump clothes dryer, and a heat pump water heater down in my garage below. So you can see these aren't spaceships to live in. They're comfortable, lovely, beautiful spaces just like any other house. They just happen to have much lower utility bills and feel a whole lot more comfortable. In terms of me, I'm a certified energy analyst. That's the CABEC, California Association of Building Energy Consultants, highest designation for an energy modeler. And I have a business called Build Smart Group, and I work with architects and builders all day long, helping them design more energy efficient buildings and show they meet Title 24. And about half my time now is spent teaching, which I love. Classes like this, demystifying heat pumps is another favorite. The Energy Code ACE class for residential architects I also teach, as well as the ones on solar and battery. And most recently been out on the road training heat pump water heaters for 3C Ren and other clients, training plumbers, I should say, on how to install heat pump water heaters right. And here you can see the proof in the pudding. This was the first full year of data after we remodeled the main house, and we overproduced electricity by about 1,100 kilowatt hours. So we got a small little check back, but it was sure nice to have no electric bill for probably 5 or 6 years after we did the remodel. Since then, a lot's changed about net metering and how our electric bills get calculated. We'll walk through that a little bit today. And of course, now it's all electric, so these numbers look a little different, but it sure was empowering as I was starting my new business to know I didn't have a monthly electric bill to worry too much about. And here are just a quick couple of charts showing you when we designed the ADU, just by going all electric, it cut the carbon emissions of that building by, what is that, 30%. And by pairing it with a 4 kilowatt solar system, it dropped that to near zero. And we actually are operating at zero net carbon. And the utility bills are minuscule too. We've rolled that into the lease with the tenants. So they pay us a set monthly fee, and we've basically prepaid their utilities by putting solar on the roof and designing it to be efficient with electric systems. Robert?
All right. Nick, do you want me to switch?
Sure.
All right, let me do that. Share, yes. And screen 2. And
I see you just got to skip those early slides.
There we go.
Don't look, everyone. Look away.
All right. Again, my name is Robert Fortunato, and it's a pleasure to be with you all today and with Nick Brown, who is one of the best energy modelers in the state. So I'm honored to be with him, and he's continuously pushing the edge of innovation on these things. And what you're seeing on the slides are what is called the Green Idea House. We built the first net zero energy, zero carbon case study house that was less expensive than standard construction. And we used standard construction materials and off-the-shelf technologies. And we came out of the ground in 2012. So for 14 years, we've been operating this building that has proven that it is less cost on first costs, and operation and maintenance costs are less on this building as well. And it's a pleasure to be in. We've had over 5,000 people through the building before, during, and after construction. We did a TED Talk about the building in 2014. And so if you want to hear the whole backstory, you can just type in my name and TED Talk, and you'll find it pretty easily. But again, like Nick said, we saw a bunch of buildings in advance of doing ours, and we saw spaceships and we saw mud huts, and we realized that people don't want to live in spaceships or mud huts. We wanted to, basically build something that people walk into and said, I could live here too. This kind of makes sense. And you'll hear in the TED Talk that, we couldn't find an architect, we couldn't find a general contractor, especially back then, who understood what our vision was for this thing. And so we had to roll up my sleeves, take a sort of a hiatus from my regular leadership strategy and innovation practice, and to do this thing. And when I got done, I wanted to go back to my regular work. And nice people like Nick Brown said to me, you can't do that because what you've done is actually quite unique, and it's needed at scale in the world. And so I've been doing this full time ever since. And I started working with affordable housing developers and auditing their buildings. So I've taken a very large number of classes on both residential and commercial buildings, and I've taken all the LEED classes, I've taken all the passive house classes, I've taken just a variety of things throughout the years. And it's allowed me to go into those buildings and really understand what the workings are and calculate what would be a better return on investment or net operating income for the owners of those buildings. And as a result, I'm currently working as an owner's representative, if you will, on some very large builds. I built a team last year that won the California Energy Commission's $1 million grant. It's called their EPIC program, to design one of the most sustainable, affordable housing complexes. And if we did well on that, the project proposal, the report, if you will, coming out of that, we would win another $9 million toward the actual building of this building. And we were against formidable competitors, and one of them was Gensler, for example, if you know who Gensler is. And we actually beat them out, and we won the additional $9 million to actually move forward with the building of this $150 million affordable housing complex in Santa Ana. So those are the kinds of things I'm doing. I'm representing owners for something called the Beach Cities Health District. They're redoing an 11-acre campus locally, and just trying to help them get to the profile of a net zero energy, zero carbon campus going forward with their build. So those are the kinds of things that I'm up to generally, but it's a pleasure being with you all today. As you can see, our building actually works. The engineers who designed it were some of the best in the country at the time, and they still are, but they were very skeptical. They actually didn't think the building would meet our goals because we disconnected the gas line, and that was a radical thing to do back then. And the energy code actually had its thumb on the scale, the side of the scale for gas at that point in time. But we proved this actually works, and it works better than gas. And as you can see from the chart, I think you're all in Edison territory. Each one of those bars on the Edison bill represents a month, and every month above the line means that we're using more energy than we harvest, and every month below the line means we're harvesting more energy than we use. And so it's really dependent on how much we drive and how much we charge our cars, but we have been net zero energy for the last 12 years, 14 years, and it's just like Nick said, it's just a pleasure not to be worrying about that when we hear about how energy is, getting more and more expensive, especially with, what's happening in Russia and, other things that are affecting the price of natural gas specifically. So just wanted to go over a couple of definitions, for folks who are not, that familiar with the space. We want to make it comfortable for you guys all to be here. So net zero energy, what we're talking about is a building that produces as much on-site clean energy as it uses over the course of the year. So that's netting it out at the end of the year. That's zero net energy. Zero carbon is a little bit different. That's a building that produces as much on-site clean energy as it uses over the course of the year, but it's measured hourly according to the carbon intensity of local energy production throughout the year. Some of you might be on time of use. Naomi, are you on time of use? Do you know? No.
I am not, but that is an offering that SCE
That is
and
an
PG&E
offering. Yep.
offer, yeah.
Yeah. And so we're going to be talking about that because the utilities are going to be pushing us all toward net zero, or I'm sorry, time of use energy metering, because the value of energy has changed over time, especially with the introduction of a lot of solar coming onto the grid. And we're going to be talking about that and why that's important, how you can mitigate that if in fact you're on time of use. And then greenhouse gases are emissions of gases proven to trap the sun's energy in the Earth's atmosphere, leading to rising temperatures. These include CO2, methane, and others. And I'm not going to be so generous. We use this euphemism, greenhouse gases. It does do that thing, but it's also pollution. And there is no way when you release pollution through your roof, it just doesn't magically disappear. You are polluting. You're causing localized pollution, which we know causes heart disease, lung disease, and cancer. And so that's also what we're trying to do here, is mitigate the tremendous cost of the fossil fuel related health impacts. And we're going to be talking about some of those today as well. But that's a big part of our mission here, is to help people have better and healthier lives. So that leads directly to why all electric. And if you guys could chime in, you're committing time today. You're committing 4 hours or 3.5 hours to be with us. And what's your opinion? Would love, please chat. Type in the chat as to what it is that you think is the benefit of all electric. Why are you interested in this topic? And would love to hear your responses to that. We'll give you a few of ours, but please, let us know a few of yours as well. We might have missed something. As somebody who's representing builders, right? One less utility, and with all due respect, because Southern California Edison is paying for this, program, our time in it anyway. But in the build, most of my general contractors are concerned about the time it takes the utility to actually connect their building to the grid. And I had a high-end developer who had a 37 unit building after the Santa Rosa fires, who couldn't get their gas meters. As a result of the Santa Rosa fires, they were out of meters. And so they had to wait 3 months. And the capital carrying costs on 3 months for them to have to wait for these meters was extraordinarily expensive for them. So, we'll talk about trenching and infrastructure and the most expensive, trade on your site. But hint, it's all related to the gas infrastructure, right? There's also an AMA study that came out, American Medical Association, that gas stoves increase household air pollution NOx and the risk of childhood asthma by a staggering amount. And so we'll be talking about that more in detail. Reduce the dependence on foreign energy. And we know what's happening, with Russia and Ukraine and all the rest of it. And Europe has felt it, significantly. But last year in February, the gas prices went from $1.25 a therm to $4.25 a therm. So those kinds of spikes can really put a shock into everyone's budget and the whole economic system. And so if we can reduce that foreign influence on our economy, it would be helpful. We talked about external pollution, GHG emissions, better backup of power and water in an emergency. And Naomi talked about the fires when we were getting on up there. And, you don't know, we're in California, right? There's earthquakes, there's fires, there's mudslides, there's all kinds of things that can interrupt potentially the power. But now we have an opportunity to be energy independent, truly. And that is something that in history we've never really had that kind of independence. So you can keep your refrigerator on, you can charge your phone, you can keep your Wi-Fi on. All the critical elements could be self-sustaining with a good solar system and a battery backup, which also would reduce your energy costs on a monthly basis as well. Improved lifestyle. Nick Brown's going to be he's going to give a cooking demonstration that's going to blow your mind. And billions of dollars in incentives and training right now, especially with the IRA, the Inflation Reduction Act. There's more money than we've ever guessed would be in this space. And Nick Brown's going to give you a profile of some of the kinds of money that you have access to, we all have access to, as a result of the Inflation Reduction Act and other things that have been in the process. Nick, do we have any responses? Anybody get back to us on what they thought the benefits were?
Yeah, well, George likes nature, glaciers, clean air, polar bears, and security.
Love that. Thank you, George.
As well as being compassionate to vulnerable people's needs to mitigate the climate crisis.
It's so important because we know where the pollution is concentrated, and it's generally by power plants that are located next to vulnerable, populations. So yes, that's exactly what we're trying to mitigate. And to prove the point, Los Angeles specifically was slated to build 5 new power plants in the Los Angeles region, all targeted in disadvantaged communities, and all 5 of them were mothballed. And why were they mothballed? Because solar paired with batteries was less expensive than the gas-fired power plant on first costs and operations and maintenance costs over time. So they are supplanting all of those power plants with renewable energy and battery backups. So it just makes perfect sense. Makes perfect
Yeah.
sense.
Also,
Nick,
Victor had a question on the AMA study. We'll get to
Yeah.
that, and we've got a link for you so you can go to that exact study.
Yeah.
Jan says one of the main objections to electrification by homeowners in her area to very high fire risk area is the increasing number of power outages.
Yes, and so that Jan is saying that it's more difficult because they want the gas.
Well, I think there's a perception, isn't there, that gas is somehow superior in times of utility outages. And I think
Yeah.
when we really think about it, that's easy to debunk that perception. But we'll talk about what the utilities are doing to, in terms of grid hardening. They're spending a lot
Yeah.
of money to reduce the frequency of outages. I think the fires over the last 5 years took everyone by surprise. I don't think
Yeah.
we realized how far down the road to a different climate we already were.
Yeah.
But I think if you look in the recent past, there haven't been a lot of power outages except in high wind areas where they're doing it preemptively to prevent fires. But a battery is the perfect solution in those areas. And there's a rebate program called SGIP that has special incentives to put in a battery in households that have been subjected to enough
Fire
public
danger.
safety power shutoffs.
Yes. Yeah. And as I mentioned before, I had a client who went through the Malibu fire, and they thought they were hardened and they thought they were prepared. They had a generator hooked up to the gas line that they thought would never go out, and they actually had a tank that stored the gas on their site with an automatic switch valve, so that when the electricity went off, this thing went on. Um, and so they were prepared, so that they could spray their pool, on, water in the pool onto the fire and all this kinds of stuff. And it was a complete catastrophe. The automatic switch valve, because of the heat, did not work. Number one. Right, it's almost a comedy. And then number two, they shut off the gas immediately when the fire started. So those two things would not have been resilient for him going into this thing. And I said to the client, I said, do you have any electric vehicles? He says, no, I don't have electric vehicles. I said, but you have a solar array. He had a 14 kilowatt solar array in his backyard, right? I said, you could have gotten batteries or gotten a car that plugs in, like the Ford Lightning, right? That plugs into your house, and got a 130 kilowatt hour battery that could have drained your pool, with that kind of power, and kept your lights on in your house and so forth. And he said, no one ever told me about that.
Right.
Yeah, but they put in all this expensive gas infrastructure. Somebody got paid very well to put all this gas infrastructure in that didn't work during that emergency. So we're trying to help people, with the right kinds of answers that actually make sense for themselves and their lives. And he went on to buy a Ford Lightning, and he has it now hooked up as a battery backup, and he has batteries in his house at the same time. He disconnected the gas infrastructure because he realized they shut off the gas in those fires, which they should. Gas company just shuts off the infrastructure. So anyway, Nick, do you want to talk about this slide?
Yeah, as you know, I work a lot with the energy code, and we're putting the finishing touches on the 2025 code right now and starting to plan for the 2028. It is a Herculean effort. But the current 2022 code, there were a lot of advocates pushing for it to be an all-electric energy code. That is, all new homes must be all electric. They stopped well short of that. They've got a lot of stakeholders' interests to juggle. But what they did do was they made a heat pump or a heat pump water heater prescriptive standard statewide, as this image shows here. And 3C Ren territory has some of the few climate zones that have the HVAC heat pump standard. Heat pump water heaters are standard in more climate zones and most of Southern California. In addition, if you do install a gas system, you're required to make it electric ready with dedicated electrical circuits, plumbing hookups, panel space reserved for the future electric version, so that even if it's not you living in the house, when that gas system fails, it's a relatively easier switch to the electric system.
Absolutely.
We also have a new compliance metric that directly measures greenhouse gas emissions, or I should say indirectly, but in effect, the effect is the same. So we have to show that our building's efficient. We have to put the right amount of solar on it, and we have to show it emits no more greenhouse gas emissions than the standard building in order to meet Title 24. That's called the source EDR metric. And then they required additional mechanical ventilation. The range hood has to move more air if you have a gas cooktop under it than if you have an electric cooktop. So a number of nudge policies here that make electric more attractive than it was in the prior code.
That's helpful. And Nick, I'm just pondering over the graphic. So is the whole state then heat pump hot water heater standard, and then the orange? Yeah, explain the orange versus the gray.
You could think of it that way, that a heat pump water heater is prescriptive standard statewide, but there's an exception for these orange climate zones where if they put in an HVAC heat pump, they can use a gas tankless water heater still.
Oh, that's interesting. That's interesting. And why those selected climate zones from your perspective?
They found that the expected utility costs in those 4 climate zones were a little bit lower with that combination of HVAC heat pump and gas water heater.
That's
whereas in all the other climate zones, they found the utility cost lower the other way.
Interesting.
That's just a guess. Don't quote me on that.
Yep. So 14. I'm just now you've got me on a little roll. So where's 14?
Palmdale, Lancaster.
So
Bakersfield.
Yeah, you would figure that the heat pump hot water heater in your garage would be a net asset given how hot it gets out there, right? So going with a tankless hot water heater, it seems to make no sense at all.
Juggling a lot of interests, Robert.
All right, sorry. I'm thinking
Better
too
keep
deeply.
moving.
Yeah, let's keep on moving. Okay.
Yeah.
All right. So Nick and I are not trained as environmentalists. We are trained as economists, and we wanted to show you these graphs because this is really why we're talking about this. We couldn't have done this 30 years ago. We could not have made this same presentation. We're sat here with any sort of credibility to tell you your bills are going to be lower, the first costs are going to be lower, because the price of solar and batteries is really what has made the difference. And specifically over the last 10 or 15 years, the price of solar has significantly dropped like a stone. And it's really the installation costs, going forward that are the barrier to this thing, because they are so inexpensive, and the quality of the panels, solid state with warranties of 25 years, ironclad. It's really incredible what has happened in the industry. And batteries are following the same trend, the technology on the batteries, and I'm expecting another breakthrough. Now we're moving into solid state batteries and other things that will make a huge change in how we store energy going forward. But it's that in combination with the efficiency of things, your refrigerator from 20 years ago used 10 times as much energy as your current refrigerator does. And so things like that also make a huge impact. And by the way, if you have that old refrigerator in your garage, think about that. From an energy consumption standpoint, we want to purge those things and put them into retirement, because they do use a lot of energy. And 100-watt bulbs were the sort of 160-watt bulbs were the standard throughout your house, right? And that's not that long ago that incandescent bulbs not only did that, but they added a bunch of heat to your house, from a performance standpoint. And now for the same, a light output, you can do it for like, I don't know, 7 to 14 watts. So it's changing the whole energy profile of the home that makes all this possible today. Also, we know the future price of fuel is skyrocketing. And we know from this Lazard levelized cost of energy analysis from 2020 that wind and solar is without a doubt the least expensive way to produce energy, followed by natural gas, coal, and nuclear. When you include the total cost of development and retiring those plants, it's extraordinarily expensive. And then when you look at the energy production over time, they're expecting the gas infrastructure to be much, much more expensive. And as we mentioned last year, gas that you see here went up to $4.25 a therm. Electricity is going up higher than we thought, given the projections, but not nearly as much as projected for gas, especially as they start to curb and close off some of the gas lines. People will sort of be stranded on a branch of that fuel, and because the number of people on that branch will continue to decrease, the cost per user is going to significantly increase. So we want to make sure that transition happens equitably, and so that's why we're doing a lot of work in the disadvantaged community area. I don't have to tell you, and I never talked about global warming, quite frankly, because it became a political football, unfortunately. But the correlation between the burning of fossil fuels that you see on the top and the average temperature, on the surface of the planet is highly, highly correlated. And as we talked about, in terms of, what's happening in the world, right? Heat pumps are transplanting the need for gas all around the world for very good reasons, depending on how you see it. But generally the influence of Russia on the prices of gas throughout Europe and related to the United States as a result. As I mentioned before, there are billions of dollars that are allocated to this effort, and that's driving a number of things. Whole industries are now committed to doing this thing as a result of the legislation, specifically SB 100, which I want to point to first, because I think it's so significant that the whole entire grid will be net zero energy, zero carbon by 2045. And so everything that we plug in is going to be more energy less carbon intensive as a result of that. The grid is currently around between 30 and 40% renewable, and again, it's going to be 100% renewable by 2045. So all your electric vehicles, everything the switch over from your gas stove to your electric stove is going to make a lot more sense when you understand that from a perspective of reducing overall carbon from the source of the energy generation.
Hey, but Robert?
Yes, sir.
The difference between renewable, we're hearing someone in the background, if you wouldn't mind muting. We might be 36% renewable, let's say, on a given part of the state, but we're 52% emission free already when you add in nuclear and you add in hydropower. So we're actually far closer to that 100% goal than those percent renewables would indicate.
Yes. And there's, so much more solar coming online every day. So that's the good news. And in California, no internal combustion engine car sales by 2035. There's all kinds of incentives that are coming forward, as we speak. But 369 billion is in the Inflation Reduction Act, and we're going to talk about how you can get some of that money specifically today. And the cities have stepped up significantly to take on the charge of creating what are called reach codes. And down here, we've been working with Santa Monica specifically to say what makes sense to help people make the transition and make the transition equitably going forward from their gas appliances over to all electric situations. And so we're just really happy to see Encinitas, Solana Beach, Santa Barbara, San Luis Obispo. No, Louis, San Luis
you had
Obispo.
it
It's
right.
Louis, right? I had it right. Ojai and other places taking on the charge to help people create better environments that are healthy for them and safer at the same time by disconnecting the gas line. And Nick, you want to talk about the incentives now? It's a good time to talk about the money.
Yes, with Naomi, if you could unmute Naomi. What's different about this go round incentive-wise is the stackability of them. I remember in the past, if you took advantage of one incentive, then you weren't eligible for another. But this time around, they're saying, look, let's say you replace your water heater with a heat pump water heater and you're in 3C REN territory. Starting from the bottom up, there's up to a $2,000 federal tax credit under the IRA for doing that. Then there's another incentive that 3C REN has put in place, and the TEC program, which is a statewide incentive for retrofitting gas systems to cleaner heat pump and electric systems, which 3C REN has a program to boost. So you're looking at a $7,600 possible incentive for that small project to replace your heat pump water heater. It's possible to fully pay for that project with that budget.
Yeah, and I
Naomi?
also want to add for the 3C REN incentives, those are based on the home energy savings after 1 year. So if you're doing retrofitting on a property that's going to have a huge amount of energy savings, if you're changing things like the HVAC and they use a lot of energy in the summer, you can earn even higher. And if you're in a hard to reach category, which includes English as a second language, tribal territories we've now learned can be part of that as well, and mobile homes. And if they're on the care rate, that you can get higher incentives as well. And I do want to mention, as I think Jan just put in the comments, some of the incentives for TEC and 3C REN are exhausted at the moment, but we are working to get those back online. And depending on your budget, like I know for 3C REN, if you're doing a multifamily project, there's still incentives are available.
And we're told as soon as August, those incentives under the TEC program may be back.
Hopefully, yeah.
And I believe they're driven by some of the federal IRA money. Next slide, Robert, I think covers some of these hard to reach and equity. You see how the numbers can be boosted for those clients. And then this is another stack. Oh, Robert, this is the out of date one. Mine I updated this. So the numbers are a little better when the TEC program comes back. But this was an incentive stack that was done when the TEC program was no longer an option. You've got the Energy Smart Homes program, which provides a base incentive of over 4,000 plus kickers for certain additional features. The TEC program, which can cover 1,000 on a heat pump, 900 on a heat pump water heater. That's going up to, boy, I want to say 3,800 when TEC comes back in SCE territory.
Wow.
Yeah.
That's amazing.
Then you've got the IRS tax credits, which allow for up to these numbers, 30% of the total cost of the project to be taken on your taxes each year. And by the way, best practice is spread out those installations so you can take the $2,000 maximum each year. PV panels, of course, 30% federal tax credit as well, even a small one from AQ&D for an EV charger. So if you're contemplating going all electric, and hopefully at the end of today, if you weren't already, you will be, the money's never been better. The timing's never been better to embark on this project than right now.
So is that new, Nick, the 2,000 per year cap? I hadn't heard that before.
I believe it is.
Oh,
Doesn't
is that
apply
right?
to PV panels, but like
It
you
do-
can't take the heat pump and the heat pump water heater in the same year.
Okay, so you really have to think about spacing this out over the course. And the good news is it's running for 10 years. So you can
Right.
methodically go through, and that's a great opportunity to do your, proactively do your heat pump, hot water heater installation, right? And
Yeah.
other things of that nature and space them out. But you could do solar and one of these things and break that $2,000 threshold, right?
Yes. And that's a 30% tax credit, as Jan points out. So a
Right.
$4,000 tax credit is based on a $12,000 or about 4 kilowatt solar system, just a typical size.
Okay.
Yeah.
Okay,
And
that's
this is for
helpful.
retrofits. There are smaller incentives for new construction as well,
Okay, that
under many of
clarification is
these
helpful.
same projects. And then if you're working with a low income family, under 80% of area median income, you can add the HERA program next sometime later this year, maybe next year, on top of these incentives we just covered. And now you're looking at a $30,000 budget to work with to electrify this house, because the HERA provides point of sale discounts up to $14,000 a household on these things you're going to need to electrify a house. The point of sale discount structure makes sense when you think about this population. They can't put out $14,000 with the expectation they'll get it refunded on their taxes in a year or two, right?
Right.
So they're offering these discounts at the point of sale. That's very important.
Makes a lot of sense. Makes a lot of sense. All right. Nick, you want to take it over from here?
Yeah, absolutely. So what I wanted to cover was some recent research that bolsters the case Robert's made so far for all electric homes. Here's the piece I didn't understand when I designed my house to be mixed fuel.
I told him though. I did tell him.
You did. You did. That they have roughly half the greenhouse gas emissions as a mixed fuel house. Look at these bars carefully. We're showing the electric and gas emissions in the mixed fuel house. And the all electric version, of course, removes the natural gas leakage and combustion portions. They're using more electricity though, right? So the green bars expand a little bit. But even today, with the grid we have now, the difference is 45% for retrofitting a 1990s style home. But the numbers look very similar for new construction and in other climate zones, as we're showing here. As the grid greens, though, those natural gas combustion bars stay largely frozen in time. You're locking in the emissions of the gas systems even into the future, while the green bars shrink because the grid energy is getting cleaner and cleaner. And look at the minuscule all-electric bars by 2050 compared to the mixed fuel bars of today. That's what the promise is of all electric homes with a emission-free electric grid look like. And that's what it's going to take to get at these extreme weather conditions that I think are becoming too impossible to ignore nationwide now. Houston had millions without power yesterday after that hurricane came through. It's just everywhere. It's not a coastal elite problem, if you will. It's getting impossible to ignore. So this is reason number one, I think. You know, if you care about, believe in that as a challenge to our society, well, going all electric is one of the biggest things you can do. And I use my modeling software to spread this out across multiple climate zones. 3 is San Francisco, 6 is Malibu, Santa Barbara, Ventura, 10 is Inland Empire, Southern California, 12 Sacramento, and you see the same relationship. The greenhouse gas emissions are roughly half for all electric homes today, what they are if you were to build them mixed fuel. And your compliance models, those of you who are energy consultants or work with them, calculate greenhouse gas emissions. So by all means, start using this as a design criterion as you design buildings. Now, a number of studies have looked at the California grid. That's the 2035 report out of Berkeley, as well as the national grid, like the Net Zero America project out of Princeton and others. And they've found that grids can transition from their current mix of resources to these emission-free mixes of resources like California has committed itself to, including intermittency, that is, wind and solar are variable, including uncertainty, all over the United States, and studies have also looked at the rest of the world, without driving utility costs higher than they otherwise would be, while creating jobs and, importantly, improving health outcomes. So I encourage you to check out some of these studies that I've found really interesting reading. And I think a lot of the language in those reports you can see echoed in the Inflation Reduction Act that was passed at the federal level, which just 5 years ago, I never thought I'd see that. And I don't know if anyone saw CBS News, I think it was a 60 Minutes report. California has an unexpected problem, too much solar. Did anyone see this report? It was just horribly covered by the national news media. And this chart shows why, okay? Solar and wind are lower cost generation resources. Pair them with batteries, you can handle the uncertainty and the intermittency and still be lower cost than the old legacy natural gas options. But you are going to have periods where you have excess solar. That's not a fault. That's just part of how this whole thing works. And it's factored into them being lower cost. All that's factored in. So yes, there's times where California is sending excess solar production to Arizona for free or paying them to take it. It's all part of the design, folks. And that's what the gray bar at the top of this chart on the right is showing. They call it curtailment. And this is the future 2035 grid shown nationwide. And there are periods over the course of a typical day with curtailment, but still the system works. So I was really flabbergasted that that made it through the national news media without being overhauled the way they covered that story. And I'm contemplating a blog post on it, Robert. That's how fired up I am.
It was egregious. It was egregious.
Yeah.
And the headline should have been, why are natural gas fired power plants still running when we have so much extra solar? That should have been the headline. And instead they twisted it the other way around, talking about curtailment. And the reason is because they have long-term contracts to run those power plants and they get paid to do it. And solar is more recent and we don't have the same kind of contracts, long-term contracts to run the solar. And that's the sad part.
Yeah. So I really like this quote from the 2045 report. Given the plummeting costs, the US could reach 90% zero carbon electricity by 2035 reliably and lowering electricity bills. Realize that if you're working on electrifying buildings, and if you're driving an EV, you're targeting the two biggest slices of the greenhouse gas emissions pie, okay? Buildings, a good quarter of greenhouse gas emissions in California, transportation, a little bit more. So working on this problem is one of those things you can do to have the biggest impact. And I know personally, that's the reason I'm doing what I'm doing. Now I wanted to show you, this is new modeling results. I know it's exciting, Robert. You're on the edge of your seat. I took a typical 2-story house, coastal 3C Ren territory, Ventura, Santa Barbara, where Naomi is today. And I modeled the hourly electricity usage for the all-electric home and compared it to the mixed fuel. And I plugged it into today's rates via SoCalGas and SCE. And I really like this chart because it shows the utility costs go up slightly if you electrify without adding solar. Nothing crazy, but hey, that's what people intuitively get when they look at their utility bills. But add a reasonably sized solar array with the 30% tax credit, right, by the way, and that drops way down to about $1,000 a year. And pairing it with a battery under today's net billing tariffs, and that's why I did this calculation, because this has been changing so fast. Now you've got more savings to have the battery than there would have been under NEM 2 or NEM 1. And you can see you can take control of your utility costs by electrifying and pairing it with solar. And look at the carbon footprint difference. Just going all electric, like we said before, you cut it in half, but pair it with solar or solar with battery, and you're cutting those greenhouse gas emissions by 2/3.
It's impressive. It's impressive. Hey, Nick, we have a question from Jan. It says, who will implement the HERA program through the RINs as well, or other implementer? And didn't realize that refrigerant leakage will continue to be a significant contributor. Can you elaborate a bit?
Let me take the first one. You can take the second one. The state energy offices are the ones who will administer HERA. So that's the CEC. The CEC, the Energy Commission, has already made its application to the federal government. It's been approved, as has New York State's and several others. So now it's on the CEC to roll this out in a formal way. And it's taken a while, right? The IRA passed 2 years ago, but we're going to get there, and that's going to be exciting. But I don't know the role 3C Ren will take on that. Maybe Naomi has something to add.
Yeah, this time I do not know.
Okay.
All right, we can get back on that one. And then in terms of refrigerants, everyone is working to diligently reduce the leakage, as well as the types of refrigerants that will be used. And in fact, 2025, starting in 2025, there will be significant switchover in terms of the requirements for heat pumps and refrigerants going forward. All of the contractors, have let me know, that switchover is affecting them, and they're having to switch out units very specifically if in fact you specify in next year versus this year. So everyone is working very diligently to reduce the application of harmful refrigerants going forward, and get them closer to just using CO2 as the refrigerant. And a number of different heat pump hot water heaters and others are using CO2 as a refrigerant. Sandon is one of them, for example, that just uses CO2 as the refrigerant.
I'd add, though, that refrigerant leakage is not an electrification problem. A house with air conditioning and a gas furnace has the same amount of refrigerant as a heat pump house. And a heat pump water heater is a packaged unit with that refrigerant charged and sealed at the factory, very unlikely to leak unless you mindlessly toss it into a landfill at the end of its useful life, which we shouldn't be doing, right? So this is a robust analysis, this chart that looks at that, but I think that's being overplayed as an electrification problem by some.
Yeah. Great question, though. Great question.
Yeah, good activity so far. Now,
Excellent.
I like to share this case study Steve Kramer's a client of mine, and he was building this 4-story multifamily building on a small lot in LA. And he said, I want you to do this all electric for me. And this was like 4 years ago. And I didn't know him to be a tree hugger, but I asked him, sure, but why? He said, doesn't make any sense to me to run all those gas lines through this building from a financial perspective. Like I said before, it's a big tent of people under the all electric umbrella. And here's a great example where he's not coming at it from a greenhouse gas perspective, just a practical financial perspective. And we were able to make this building work all electric with a heat pump water heater in each unit or in the hallway out each unit, a ductless mini split in each unit, condensers on the roof. It required some electrical upgrades through DWP, but would have required those anyway and met the energy code.
All right, Nick, want me to get over from here?
Yeah, let me stop.
All right.
Tell us the solar and battery picture, the enabling piece, right?
Absolutely. So what we're going to do from here is walk through each one of the technologies and talk about really what everybody should be thinking about as they move through this process of electrification, from the electrical infrastructure, the solar and the batteries, the heat pumps, the heat pump hot water heaters, electric and heat pump clothes dryers, and induction cooktops. And Nick is my hero because he actually tried one of the first of anybody I know, heat pump clothes dryer, and actually encouraged me to switch over, and I switched over, and we love our new unit. So couldn't be happier with it. That heat pump clothes dryer. So as you can see on the right, there's the energy use in Southern California for gas and the distribution of that. Or no, that's total energy.
That's overall.
Yeah, overall water heating 14%, heating is 16%. As you can see, cooling 29%, and the appliance plug loads and lighting are 41%. And I still have to get a handle on that because my son bought a flamethrower of a computer. He put it together himself, but it runs like 400 watts. And I was like trying, like our laptops run on 20 watts.
Right.
So I don't know what to do about that, quite frankly,
right.
other than get a little bit more solar. But anyway, that's a personal problem. So again, we go back, we couldn't do all this without the price of solar and batteries decreasing significantly over time. That creates the frame for everything else that we're doing. But the electrical infrastructure is really critical to think about. We've gotten into situations where clients come to us at the last minute. There's a situation in Santa Monica where, and this is what happens all the time, right? The developer finds a piece of property, and then they go, and what do they first do once they find the piece of property? They get an architect to say, how do I max out that piece of property? How many units can I get on that piece of dirt is the first question that they ask. And the architect diligently maxes out every square inch to get the maximum number of units that they could either sell or rent out on there to maximize their return on investment. And they don't think about the transformer. And especially in multifamily buildings, there's a very specific requirement for that. And there was a developer who did this exercise, and they went to the city of Santa Monica at the last minute, and city of Santa Monica says, you've known about the all electric code for a long time now. How is it that you're bringing this project to us without the need, for a transformer? And the developer was not happy, but they, ultimately had to do something different. They had to, bring their building back to allow for the transformer. And, in this case, it's really, really important to think through the implications because many multifamily projects will need transformer upgrades. Many single family projects will need panel upgrades. But not all of them. And we've been working with the Watt Diet process to really understand what's necessary. So many buildings actually don't need that, as a result of what we talked about before, that all of the circuits that used to use 100 watts, circuits for light lighting, for example. Now they're using 14 watts for each one of those lights. And so there's a way to recalibrate how much actual energy the panel's using, and then maybe split some of those breakers into dual breakers and actually, double the amount of possible utility loads that you could occupy in that box, but not doubling the actual amperage of the box. So we've been successful in doing that in many cases. So don't immediately think that you have to do a panel upgrade. But
And we should plug our class, Robert, in
Yeah,
October for 3C
that's great.
Ren. Yeah,
Tell them about it.
electrification with panel constraints is the name of that class, because we recognize this is something that gets brought up a lot of times, that I'm just not sure I can do it. And my electrician saying I need a 400 amp panel, which seems more,
Exactly.
they seem to say that more often than
Crazy.
I'll make it work.
Crazy.
Yeah.
And what's the date of that, Nick? I know it's in October. Do you know the date?
No, but I'll look it up.
All right. And then we really want to calculate the loads and do site planning early. The utility typically pays for the transformers, not the customer, but it does need a 10 by 10 footprint for a typical multifamily building. All electric peaks usually are slightly higher than mixed fuel, and plan for a 2x transformer size for future charging loads as well. The charging loads are really going to be significant, and a game changer for those things. And we're trying to advocate for bi-directional charging capabilities, because those batteries could be part of the solution as well going forward from there. All right, so now that we've talked about infrastructure, we want to talk about how solar plays into this. And Nick talked about it, talked about it a little bit previously, but PV has been required on all new homes as from 2020, but it's been really minuscule and generally not covering the total load. And you think about it, most solar installers won't install a 2 kilowatt system, for example. That is oftentimes what is specified given the Title 24. So you want to put a solar installation on there that will cover your current electrical loads, your future electrical in-house loads, and the electric car that is inevitably coming, because they're getting less and less expensive and will save you thousands and thousands of dollars on fuel charges and operations and maintenance charges for your car over time. So what you're seeing here on the right is Nick's house, and the blue mountain in the middle is his solar array, and what that's the load generation from his solar array, and then the load profile in green below is what's operating in his house. And what we want to do is, as much as possible, use stuff under the mountain, is what we're saying, is charge pre-cool your house, charge your electric cars, run the washer and dryer, do all that stuff in the middle of the day, do your dishwashing in the middle of the day. Like, that's while you have solar, you want to use that because there are what are called non-bypassable charges. When you use it outside of the solar window and you break that sort of mountain and you go through it, there are things called non-bypassable charges which make your bills higher. So if you can do it under the mountain and under that load profile, it's much less expensive to do that. And we talked about time of use. This is related to the time of use metering process, right? But we want to maximize as much as possible that load profile. And we want to do the basic stuff, which makes a difference as well. We want to have the building heat and cool itself. So the building shell, insulation, all that stuff makes a difference as well, to build that into the process. And Nick has created a couple of load profiles. One he calls the McSolar house, where that's a standard house where you sort of overbuilt the house. And as a result of that, you put just a ton of solar on there to mitigate the fact that you've sort of overbuilt the house. And we see that a lot. And as I mentioned before, this person who built a 14,000 square foot house, put a 41 kilowatt hour, 41 kilowatt system on
Wow.
their house, which was just a mountain of stuff in their yard. It was kind of crazy. And what we want to do is reduce the load first and create a solar system that actually marries with that load. And on the bottom, you see Nick's house, which is a lower load profile, and it marries better. There's still some residual at the end of the day that is natural. That is, people are cooking and people are doing stuff at the end of the day that's unavoidable. But that's where the batteries come in. And so if you can pair it with the appropriate size batteries, you can actually reduce that load profile and the resultant charges at the end of the day, which tend to be more expensive.
It's worth pointing out both those houses are zero net energy.
Right.
Yeah.
Yes. And this is a little graphic that we like just to show. So, just very simply, there's less excess solar exported to the grid in the middle of the day when you use that energy, right? And that's what we want to do. We want to charge all the batteries. We want to charge the in-house batteries. We want to charge the batteries in the car. And then from the 4 to 9 period, you can discharge those batteries. And we'll talk about a different kind of battery. And you can see the rates here, up to 60 cents a kilowatt hour in the middle of the summer, right? So pretty darn expensive. So we want to watch those TOU rates. And if you do have heat pump hot water heaters or EVs, you can get a special SE TOU prime rate, which means that the shoulder times will be less expensive, but those peak times go up to 62 cents a kilowatt hour in the summer. So just be careful and know what that timing is, and understand how you're orienting your solar panels as well. People used to say just orient them south, right? But now they're understanding, as a result of that, when the sun sets in the northwest sky in the middle of the summer, you don't get the advantage of the solar at the end of the day. So the orientation, a southwest orientation, is actually preferable, especially if you have time of use, because the southwest orientation still gives you a lot of that sun at the end of the day as the sun drops in the northwest sky, that you wouldn't get with a full south orientation. So it does make a difference. So make sure to calculate that and think about that as you're doing solar. We also want you to think differently about what batteries are. Batteries, people used to think, that's the battery, the Tesla Powerwall is the battery, right? And not necessarily. The heat pump hot water heaters that we're talking about are really very, very sophisticated tools in this exercise. Not only are they, not burning fossil fuels, but they have a tank to them, and there's a resiliency to this tank that is really helpful. And what you're seeing in front of you is what's called the duck curve, DUCK curve, because it looks a little like a duck. And you see the belly of the duck there, and the belly is really how much solar has been put on the grid over time. And the number of years, as you can see, it sinks lower and lower because there's more and more solar going onto the grid, which, as a result of supply and demand, makes it less and less expensive to use solar energy from the grid during those hours. And so the grid prices have dropped during those hours, and but they peak at the head of the duct, if you will, to the right of that, where you see the discharge. And so what we want to do is store as much of that energy that's created in the middle of the day and discharge it at the end of the day. And you can do that with a heat pump hot water heater. It has generally a 50-gallon tank. And what we do is we overcharge it in the middle of the day. That is, we run it at 140 degrees, and then we can turn it off from the 4 to 9 period. And it has controls in it that allow you to do that with your phone. You just basically set it up so that, it charges up to 140 degrees. And the newer ones actually have anti-scald valves on them, so that you get all the advantages of that 140 degree water. And no chance of burning somebody with a temperature, but it gives you faster recovery times and longer showers, longer hot showers as a result of that. And so that's kind of how. And people have said to me, "Well, but isn't that so wasteful because you're running it at 140 degrees?" But it's really incremental. The old gas-fired tanks, you couldn't insulate all the way around the tank. And the flue in the middle of it, as well as the bottom of the tank, could be insulated because there's a flame basically going through there that would melt the insulation. But with these new tanks, the heat pump technology means that you can insulate all the way around it. It's like having those thermoses that you pour coffee in the morning, those vacuum thermoses. And then at the end of the day, you still have piping hot coffee. So the energy efficiency of these things is tremendous. The average tankless hot water heater, for example, the total efficiency of it is somewhere in the neighborhood of 93%. And these are about 350% because of that very tight insulation around the tank, as well as pulling hot air from the room into the unit. So the unit doesn't have to make all the energy. It actually uses the energy from the room to heat the hot water. So that's kind of a little bit of how they work. And then you see the Ford Lightning on the left there. So that's another tool that can be used. My neighbor has one. He has a pool business and he bought one, and he does some really interesting things with it. Not only does he mitigate the 4 to 9 period, but he charges his Lightning that then charges his other electric car. He charges his second electric car from his Ford from his Ford Lightning, which is really interesting. But he's really trying to mitigate the charges from 4 to 9 is essentially what he's trying to do. But he runs his house off of the Ford Lightning, and he charges his other car at the same time because that thing has a 130 kilowatt hour battery in it. Just to give you a sense, the Tesla Powerwall is 13.5 kilowatt hours, and it costs about $12,000. Just to give you a sense for electric vehicles, I have a Chevy Bolt and I have a Tesla, but my Chevy Bolt has a 60 kilowatt hour battery in it, and it cost after rebates $24,000 with everything else added up. So if you do the quick math, that means that we've got a huge battery at an incredibly discounted rate, and we got the car for free, is essentially what's happening there. The next generation of all these GM cars will have the connection to the house. So they will have that kind of grid connectivity to use the car as a charger for your house. So that's all coming. But we wanted to give you sort of just a sensibility of how to best use that kind of both thermal and regular battery storage. Like we talked about with the fires and the floods and the mudslides and everything else like that, that kind of bi-directional charging, is invaluable from a safety standpoint. So that's really what we'd love to see. And I think more and more of the manufacturers are picking that up. I know that Kia, Hyundai, all the new GMs, and Ford is moving to that profile as well. I heard Tesla is also moving that direction. I think they haven't done it already because it would hurt their battery sales in their houses, house battery sales. But I think they're moving in that direction as well. Okay, I think we talked about battery storage. I don't think I need to do anything with that. And Nick, you're going to talk about the Title 24 compliance on that specifically, but there's a huge incentive on that. We understand resiliency. There's a number of applications for that, but given time, I'm going to switch it back over to you for all electric modeling.
I was thinking the same thing. We're on the same wavelength, Robert.
Yeah.
Thank you. And quickly, let's do this section and then take a break. Maybe some people are overwhelmed with the amount of information we've been covering. If you have any questions, now's a good time. And I did put the electrification with panel constraints class in the chat.
Awesome.
although it's not available for sign up yet. Okay. So first of all, this is a chart showing California's per capita electricity usage going back to the 60s compared to the rest of the countries. It's a huge difference, isn't it? Ours has stayed roughly flat while the rest of the countries has doubled. And I think our energy code, Title 24, is a big part of the reason why. And we can all take some pride in the fact that this line is actually trending down over recent times, which is what it's going to take, right, for us to get a handle on greenhouse gas emissions and extreme weather events. So Robert is my hero. He took an energy modeling class, even though it's not what he does for a living, because he understood what an important factor it is in how a building gets built. It can impact the cost, delay the project. You can identify energy savings options if it's done early enough in the design process that pay for the cost of the energy modeling services many times over. It's required. And by modeling the utility use of the house, you can size a solar system with information rather than just based on what Title 24 requires or what your roof might fit or what the solar contractor might think was the perfect amount. So we're going to try to leave you with the right questions to ask your energy consultant. Now, there's two ways to show compliance with the energy code. You can use the rigid prescriptive method, which says, I'm going to meet every single one of these prescriptive requirements in the energy code without exception. Or most projects, 95% of them, I'm told, use the performance method, which allows trade-offs. So maybe you have more than 20% glazing, which is a prescriptive standard on your building. You need to use the performance method. You're going to take a small penalty for having that extra glazing, but you'll make up for it elsewhere with added insulation or a heat recovery ventilator or a really efficient ductless mini split heat pump or all of these things. So that gives designers the flexibility to meet the energy budget in a way that their client needs are really met. And over the course of doing multiple projects, the most value-added features tend to work their way into architects' designs. It really provides a platform to do what-if analysis. You've built this model to show you meet Title 24 anyway. Why not try a few different insulation levels and window sizes and window types and really use the model the way it's intended to be used to fine-tune your design. Now, the energy code compliance metrics have changed a lot lately. Remember, the 2019 code instituted the solar mandate for new single-family homes? Well, at that time, we added this total EDR metric. So we had to build an efficient house first, as measured by the EDR efficiency, just like we always had back in when the compliance metric was TDV, or time dependent valuation energy. We just started expressing it on a term from 0 to 100. We indexed it, if you will. But now, in addition to building an efficient building, we also have to put a right size solar system on it, and that is measured in the EDR total metric. So we couldn't do a McSolar under the 2019 code where we built a completely inefficient building that didn't meet the efficiency standards and just threw a ton of solar on it, right? That's how the two metric system works. Although additions and alterations stuck with the TDV single metric because there's no solar required on those. Well, now in the 2022 code, we've added an EDR source metric. That's the proxy for greenhouse gas emissions. So if you're trying to comply with the energy code using gas systems, that's the metric that's going to suffer. And remember, we showed that climate zone map of California showing you that heat pump water heaters are prescriptive standard in 12 of the 16 climate zones. Well, let's say that's the standard design and you're trying to put in a gas water heater. You're going to really suffer on that source metric as well as the efficiency metric, but especially that source metric, and have to add other expensive features to get back into compliance. So the 2022 code made a huge step by adding this compliance metric in terms of encouraging electrification. And this is what's included in those compliance metrics. So in practice, it means you're going to get a report from your energy consultant showing your project efficiency EDR, total EDR, and source EDR, and all three need to be lower for your proposed building than the standard design. That is, the compliance margins need to be positive for you to comply with the code. Now, let me tell you quickly what's happening under the hood when you do an energy modeling run, because I think it helps you understand it. When you draw up your proposed house and you put it in a climate zone, the software makes a mirror image of your house in the same climate zone. You tell it what features you want to build it with, the envelope, the mechanical systems, the glazing, and you tell it what size solar system you want. And the software is going to put the prescriptive standard features in the standard house. And it's going to calculate over 8,760 hours of weather data for that climate zone, how much kilowatt hours and therms your proposed house is going to use. In this case, 1,962 kilowatt hours because it's all electric. It's going to convert that into the EDR efficiency, total, and source metrics. And it's going to do the same for the standard house, which in this case has gas. And our proposed three metrics need to be less than the standard three metrics, which they are in this case. So our building complies. So maybe that helps you understand what's going on under the hood just a little. Now, battery storage has a big compliance credit, just like solar had a big compliance credit 2 and 3 code cycles ago to encourage early adopters to install it. Well, now we're trying to encourage early adopters on batteries. So there's a self-utilization compliance credit available for new construction projects that incorporate batteries. And it's a hugely valuable credit as shown by this chart. The EDR impact on average is 5 efficiency points or 11%. The impact on total EDR is even larger, and source is even larger than that. So this is one of the few things that could allow you, for instance, to use a gas water heater because it has such a beneficial impact on the source energy metric. So that's out there to encourage you to put in that battery storage system on top of the resiliency benefits that you can keep the lights on and your food from spoiling in the fridge and turn on the news even when the power's out. That's called the grid harmony benefit, is why it's got an energy code compliance credit in the code.
Beautiful.
Robert, do you want to break here or do you want to cover this section first? What do you think?
Your call. You know, let's leave it up to Naomi. I mean,
Yeah,
we
what
just
do you
want to take
think?
a 5-minute break, basically.
Right.
Naomi, what's your thought? Now or a little later?
I guess how long is the next section? Because we're almost at the halfway mark of the course, but I don't know how long the next section is, or if anyone in the chat wants to chime in, I'm fine either way.
Mm-hmm.
So the next section, it does lead into the demonstration, right, Nick?
Right.
But we
Let's break now.
we usually break at the end of the section, and then you show up at the end of that in your kitchen, right?
Yeah.
So do you want to do it that way?
If there's no objections.
Yeah, if everybody's okay with it, let's just do that. Let's just
Okay.
plow forward. Yep. Okay, I'll take over.
Yeah.
And we'll go from there. Yeah, let's just continue on.
All right.
Okay, you guys see my screen okay?
Mm-hmm.
Super. Okay. So again, we're moving down the technologies. The next technology is induction cooking. And as we mentioned before, there are so many benefits to induction cooking. And who was it who chimed in who said that they loved induction cooking and then they had their son who's very like a mechanical engineer or something. I love that comment, and he loves it as well. Like anybody who has, was it Peggy? Yeah, I think it was Peggy.
Yeah.
Thank you, Peggy. Even the fussiest home chef will love it. And so love that. Anybody who's experienced it knows, and I'm just going to move down to that slide real quick, right? We've done the studies when we've asked people, you know, what's the biggest objection to going all electric? It's the gas cooking, right? People are, you know, just have this fantasy romance with gas cooking. But when they did the actual research and asked people before they had tried induction cooking, how positive were they about it? It was only 21%. After they tried it, it was actually 91% positive. So the numbers changed significantly as a result of that. And the best chefs in the world have already made the transition, right? So they already knew this going in, and they understand in commercial kitchens specifically the burns that you get from the irons on the gas stoves, the fact that you have to stand in front of 110-degree, you know, furnace essentially all day is uncomfortable, and they're breathing in all of the nitrous oxide, the formaldehyde, and the other stuff that comes off that all day. So it's really, again, the best chefs and the best cooking schools in the world have already made the transition. They know it's better, faster, and just better for your health to do that. There's so many advantages. So, you know, we all need to get on the program. This is the Consumer Reports ratings of these things, and Consumer Reports is not like a leftist rag by any means. I think it's produced in Pennsylvania. I'm from Pennsylvania, and so it's really about performance. And so you can see the top two stoves are induction, and the third one is gas, the LG Signature, but it's twice as expensive as the next one up. And anybody who knows anything about cleaning gas appliances, it's a nightmare, right? Whereas a glass surface top is just so much easier to maintain and clean. It's just ridiculous. And then in terms of the pricing, right, these things have dropped like a stone in terms of price. And if anybody would like to try one, I've got clients who have gas stoves that they have a Wolf gas stove, and they got rid of it as a result of changing over to induction once they tried the induction. But if you just want to try it sort of temporarily, there are places where you can, you know, borrow them. So for example, Southern California Edison has a lending library, a tool lending library, and in there they have these small induction cooktops. Certain libraries are starting to carry them that have sort of tool exchanges and so forth. But if you just want to get one from IKEA, it's $60. Just know, oh yeah, there we go. 3C has one of those programs, so you can borrow it right there. But know that the cooktop ones, the countertop ones, are 110 plugins, and so they will be half of the speed, if you will. So in our 220 version, we put a pot of water on the stove to cook corn or something, and within 2 minutes it's coming to a rolling boil. It's crazy how fast these things actually work. The other objection is, oh, I have to buy all new pots and pans. Not really. So you can test your pots and pans just by putting a magnet on the bottom. If they stick really well, you know that pan can work really well. We bought a whole set, but some of my clients, my developer clients, say, you know, hey, this is a big problem. I said, you know, buy your tenants a set of pots and pans for $119, and they will love you forever. And you know, it'll make it seamless for them. It's not the switchover is not a big deal. And if they use cast iron already, that works fabulously with these induction cooktops. So it just needs iron in it. And The technology is getting more and more sophisticated. A lot of people said, well, I can't see if it's hot. Well, you just put a little grease in the bottom of the pan, and anybody who cooks anything knows that that's how you tell how hot a pan is. But they're actually putting LEDs on the sides of some of them to show sort of a flame height to give you a sense for what that looks like. Personally, I don't think that's much of a, anybody who cooks understands that. And then Nick actually, like he always does as the good building scientist that he does, measured the load profile of these things. Nick, you want to talk about that?
Yeah, this is our family of 4 in the main house, and you can see it's using 15, 20 kilowatt hours, maybe a little bit more some months, but very reasonable, very affordable. It does take a large breaker to run an induction oven,
This is
but
very
not
true.
a lot of electricity. It's very affordable.
Yeah, and the efficiency comes, they say that 40%, a full 40% of the energy from a gas flame on your cooktop is actually lost to just environmental heat loss from the gas flame to the bottom of your pan. It's just gone. Whereas the induction cooktop uses magnets to vibrate the molecules in the bottom of the pan. So the bottom of the pan becomes the heat source, if you will. And so there's the loss between the magnet and the bottom of the pan is minimal. And so you get just a lot more bang for your buck from an energy standpoint.
80% or more efficient, right?
80% versus 60% efficient
yeah.
is what we're talking about. So embracing the better technology, and somebody just talked about the NO2 health impacts of electrification. Nitrogen dioxide is oh, that's you, Nick. Okay, that
was me.
Yeah, that is you. Okay, embrace the better technologies. So again, the AMA study is damning. UCLA study found that 90% of homes exceed NOx limitations after 4 hours. 4 out of 9 natural gas cooktops exceed NOx. RMA study, 20% of childhood asthma in California is due to gas cooking because those gases drop to the floor. So your kids and your pets are negatively affected by that gas cooktop. Even if you have a decent vent fan, that's still happening. And so children living in homes with gas are 34% more likely to have asthma. That is just sad, folks. We need to get these things out of the house. Gas cooking require high-end range hoods for 2022. This is a code requirement. So Nick, you want to talk about this?
Yeah, this is a mandatory requirement. Used to be 100 CFM was all you needed to vent any cooktop. Now we recognize that gas ranges add additional pollutants to the air, so higher CFM is required of gas ranges than electric ranges, another nudge towards electrification. And furthermore, more airflow is required for smaller dwelling units. And that threw me at first. Maybe it throws many of you, but it's because the concentration of a single cooktop in a small space is higher than the concentration of that same cooktop in a larger dwelling unit. So you need to get those pollutants out of there quicker.
Yeah. And you've taken all of this time, especially, folks up there, you're dealing with smoke issues. And so you have your windows closed and you have your air conditioner on, and you've paid to get this quality of air in your house. And now you have to turn on a fan which pushes more of that pre-treated, pre-cooled air out into the environment. So it's actually less efficient because you have to do that because of the gas cooking. All right, now we're ready for a break.
Let's do it.
Right. All right, I'm going to stop sharing, Nick, and then we're going to come back with you in your kitchen. And right.
I've got.
All right, whenever you're ready.
To Josh's question, I've got my big cast iron pan here. I use it all the time right here. Really puts a nice sear on a steak. Gets hot fast, whereas usually heating those up over gas takes a lot longer. And I found these ceramic hard tops to be very durable. This is what, 9 years old now, and there's there's nary a scrape on here. It's got 4 burners. I shouldn't call them burners anymore, should I? 4 hobs. And I think a lot of you will like the fact that the controls are touch button. So I can dial up the heat here using this control. I know that when I'm boiling water like I am today, I'm going to use the high setting to boil it and then put it on 3 or 4. I usually run rice at 3 and oats at 4. And I think those digital controls are really appealing to people as opposed to the dials where you're gauging it based on size of the flame or whatever. You'll also notice that when you take a pot off like I just did, it turns off the current to that hob. So that's a huge safety feature. It can sense the pan when it's in place and turn off when it's removed. This is a nothing special emerald pan that probably is 20 plus years old. He hasn't been on the Food Network in a long time. Just to show you, it doesn't take fancy pans to cook with induction. So I'm just making a cup of rice. So I'm putting a cup and 3/4 of cold water in and the cup of rice. And I just want to show you what it's like. This is the smallest burner I have, and I'll put it on maximum and we'll just time together how long it takes to get boiling. In the meantime, I want to talk about the safety. Think of, Thanksgiving and you've got little kids running around and they're going to be reaching up over the side of your countertop. That's a really scary proposition with gas cooking when that whole surface is hot. But because the magnets and the heat are confined to the space that you're cooking on, I find no heat around it. I find I can clean up spills around the pot while it's running. That's how not hot it is in the near vicinity. I can pick up the pot's handles like I never could with gas. So safety is a huge differentiator. Health, as Robert just covered, is the other huge differentiator. You still need a vent hood, as you saw in the code, because you're still creating moisture, which you need to get out of your house. You're still creating cooking compounds, which you need to get out of your house. But it's far less of a health imperative than when you're cooking over gas, as those research studies we cited show. The water's already starting to bubble and stir. We generally say it boils water in about half the time. So that's a really nice feature. I find when I'm following a recipe and it says, you get to step 4 and then it says remove from heat, I don't have to do that. I just turn it off and it's removed from the heat. So it's like a relic of the old way of cooking. We got a strong boil on this already now. So I'm just going to dial this down to 4, put on the lid and let it simmer. So I've found the cooking experience with induction sort of like the driving experience with an EV. It's hard to go back. And at last Thanksgiving, I made a gravy, an onion gravy with wine, I think it was. I practiced here to make sure I could do it. And then our Airbnb had a gas cooktop and it came out nowhere near as good. The experience, the digital controls is far and away better. You've got pinpoint temperature control, and you're able to, I find I'm able to go from a medium hot step of the recipe to a medium step of the recipe a lot faster too than I could on gas. Josh or others, any questions?
That was that was very helpful. Thank you.
Okay. And like I said during the break, this is a drop-in cooktop separate from the electric oven, but they make slide-in units that are a little bit more affordable. They make 24-inch units that require less heat, less power. This is a 30-inch. that requires 50 amps and 240 volts. So it's a big circuit to go to induction, but well worth it. Yeah, durable, easy to clean. We've been very happy. Robert, anything to add from your induction experience?
Yeah, we've had ours now since 2012, and people come in and they can't believe it's that old. It's just, it looks like brand new. So it's, you know, very easy to maintain, and just, we love it. Would never go back. Would never go back.
Good. And you're coming through really well.
Super.
I just spotlighted you, so everyone should see Robert full size from his garage. So take it away.
All right. And there's a message from Peggy in there. Another bonus induction cooktop and additional counter surface when burners aren't in use. Absolutely. We
Good point.
Yeah, I put a chopping block on there and use it all the time. It's really helpful. Super great, Peggy. All right, so you're in my messy garage. I'm not going to pan more widely because it's so messy in my garage. We have 20 different projects going on in here. But what I wanted to show you is really the totality of the heavy duty mechanical lifting that's happening in our house. We built a house to basically heat and cool itself, so it has heavy overhangs on it. And the stairwell is a thermal chimney, which evacuates hot air in the house. And so the house generally stays very cool in the summertime, and heats itself in the wintertime because of the angle of the low hanging sun in the sky that comes in below the overhangs during the wintertime, but comes high in the sky in the summertime. And so those overhangs provide shading. That has worked beautifully. The insulation and air sealing that we did have worked beautifully. And so it just really needs a smidge of mechanical heating, because we're in climate zone 6, as you guys are, you know, Santa Barbara, in San Luis Obispo and other places up there. So very similar climates. The thing that we saw when we went on homes tours, the green homes tours, if you will, was kind of shocking for us. And in that there was always this room with this, it was like the engine room of a submarine or something like that. All of this plumbing and all of these dials and all of this crazy stuff that we knew we never wanted to build. We don't want to build it. We don't want to pay for it. We don't want to maintain it. And oftentimes people don't know how it works. And so it's really expensive to get a plumber or somebody to come in and fix the thing, is what we found. And so we didn't want one of those. We wanted to keep it really simple, like off the shelf technologies that people can understand. And so, so this is what we ended up with. Behind me, you will see 3 tanks, right? The first tank is actually a passive tank, in that I have my garage door faces southwest, and we put windows in the garage door so that it passively heats this garage space. So the heavy thermal stuff like the cement and everything in this space gets heated up passively by the sun. You don't need this. This is just kind of an added bonus. But this, as a result of that, this garage stays about 70 degrees all year long. And the water coming into that tank from the outside comes in from the city at about 55 degrees in the wintertime. And as a result of just sitting in this space, it naturally gets up to 70 degrees by itself, just by sitting in this old tank. And this is the old gas tank that was in our house for 15 years. And my son and I just basically stripped the metal jacket off of it and scraped the insulation off of it, and we painted it black and red, just from a rust proofing standpoint. But that's what that does. It's dumb, passive technology to do that. You don't have to have that for any of this to work. It was an experiment, if you will. And if we were to do it different, we might do it differently next time. I would put it further away from these units, and I'll tell you why in a second. There's a piece of cardboard between this and the second unit. Second unit you see is one of the first GE models that came off of their factory floor in 2011. 2010 probably. And we actually stalled our project for about 6 months because we were waiting for these very specific units. These are the first commercially made heat pump hot water heaters in the country. And we just knew this technology was a game changer. Why was the technology a game changer? It's we did the back of the napkin math on it. And it's a game changer because the solar thermal panels are relatively expensive and they sit on your roof. And if you are not using that hot water, the return on investment approximates zero. The comparison is if you're not using your that is your PV panels, photovoltaic panels, which create electricity, the electricity goes out into the grid and you get a credit for that electricity. Whereas you don't get a credit, and it's really it's hard to store and expensive to store the solar thermal energy from solar thermal panels. So we did the quick math, and that's one thing. So if we go on vacation for 2 weeks, the return on investment is zero for that 2 weeks that we go on vacation. That is, no one will be using hot water in our house. Whereas the electricity from the PV panels would be going out to the neighborhood. And even when I'm on vacation, I would get a credit from those PV panels just doing their business while I'm away on vacation. The second thing was the warranty periods, right? You have water and electricity moving through pumping. You have to put glycol on one side of it. It has to have a heat exchanger. Like there's a complication to the solar thermal that we just didn't want to deal with. It's only got a 10-year warranty, and PV and inverters have a 25-year warranty. So that's another case. And then we couldn't find a solar thermal system that had been through more than 5 or 8 years without a major overhaul. So from an operations and maintenance standpoint, that's really not what we wanted to sign up for. We wanted stuff that was like solid state, that didn't need continuous operations, maintenance and repair stuff. In addition to that, the solar thermal panels took up a lot of the square footage on our roof, and we wanted to allocate that differently. So for all those reasons, we sort of stopped our building process and we waited for these units to come, because this was a real game changer. And it's hard to imagine now, but 14 years ago, there wasn't really a very efficient way to make hot water.
With electricity. Right.
With electricity, yes, and this is it. It does have a resistance heater in it, 4,500 watt resistance heater, but we've programmed in. You can program in to turn it off, so it only operates by heat pump only. And in the heat pump only mode, it is super efficient, and you don't get the demand spikes from it because the maximum operational load from this thing is 500 watts. It sort of ramps up from 200 watts to 500 watts at the end of its cycle. And so it doesn't use much energy at all. And if you wanted to have hot water on your critical loads during emergencies, for example, because it only uses 500 watts, you could actually have hot water on your critical loads panel as well, which means, in a backup, when the electricity goes out in the neighborhood, you could not only have your Wi-Fi, your refrigerator, but you could put hot water on there. It's reasonable. It's a reasonable load to do. So we have it locked out, and it only goes in heat pump hot water mode only. And because we have it programmed to 140 degrees, we can take multiple hot showers. The three of us like hot water, and we take long showers, and we have taken them serially and not run out of hot water. So it's not a problem with this particular unit. The other thing that we love about this unit, I don't know if you can read that, but it says vacation or away mode. And sometimes we like to travel, and so we might be gone 2 or 2.5 weeks at a time. I can hit the vacation mode and program it up to 2 weeks away. It'll turn the thing off completely and then turn it back on the day before. I can program it to turn on the day before we come back. And we love that feature. It just uses 0 energy during the whole time that we're gone, and then turns itself back on, and we have hot showers. You get off the plane, you can come home, take hot showers. It's not a problem at all. So that's what this does. It's a really maintenance-free unit. You'll see at the bottom, I actually have a bucket down there. You see the bucket? It creates condensate because it's like a reverse refrigerator in that it's taking the air in this room, the warm air in this room, and pushing it into the hot water at a very, very efficient rate. And you end up with condensate because it's like an air conditioner in reverse. And the condensate I put into a bucket because I can just throw it onto my plants. I actually have the plumbing by code that takes it outside, and I could connect that up very, very easily. But we actually like just throwing it on our plants, you know, for whatever reason. So we get probably a 5-gallon bucket every month, I would say. If in the rainy season, it's probably double that. But an interesting thing happened in that it rained on us in construction before we had the roof on. And I was not happy about that because I called the roofing guys and said, please come before the rains come. And I gave them like a month advance notice, and they dropped the ball. And it rained, and all of the lumber got soaked all the way down into our crawl space. The whole thing, you know, I had to get a shop vac, and it was a nightmare, you know, vacuum up the puddles. And this thing was, you know, operating and going after we started the house up, and it was delivering about 5 gallons a week. And then all of a sudden, probably 9 months into it, it went to like 5 gallons a month, right? And I was afraid there was something wrong with the system or something had happened. And I called my good friend, Gary Klein, who's an expert in the area. And he said to me, congratulations, you've dehumidified your house in your crawl space. So I didn't realize that that's, you know, what it was actually doing for free. So the extra bonus on this thing is it cools my space and it dehumidifies it at the same time. So if that's helpful to you, as it is to us in this, again, we have a crawl space and we have a garage, which dehumidification actually feels good in here. And it keeps the silverfish down, you know, because silverfish like humid environment. So it really is beneficial that this thing is operating in here. So it's very easy to maintain. There's a filter on the back. So probably once a year I take that out and I hose it down. I put a valve on the bottom, if you can see it right there. Yeah. And that valve, if you put a ball valve on the bottom of your tank and then purge it, you know, once a year, it'll get the, you know, particulate matter, the calcification stuff out of the tank. And if you change the anode rod once every 5 years, they say these things can last almost indefinitely. So that's the maintenance schedule that you should think about for these units. So again, the water comes in from the other tank and hot water goes out to the building. It's really that simple of an equation. Any questions about the heat pump hot water heater?
Is that 50 gallons?
This is 50 gallons,
okay.
Right? So there's a 50-gallon tank that goes down from here, and the heat pump hot water heater is this top portion right here. It does push out cold air, so you have to know that. So when the unit's running, it is actually cooling the space like a little air conditioner, like probably somewhere in the neighborhood of like a 3/4 ton air conditioner. And so as it's pushing that air out, I don't want it cooling off that tank for the reason I talked about before. So I've just put a piece of cardboard there, and I don't want it blowing cold air into the unit next door because it's going to make that unit less efficient. So I put these cardboard barriers up, and then the cold air drops to the floor where it's not going to go into those other units. The third unit I have is bigger. This is an 80-gallon unit. Same thing though, operates exactly the same way. And but it does something different. It runs a loop of hot water around our house to heat the building. It's our only heating source for the building, aside from the passive heating that I talked about earlier. And it has a pump, a Grundfos pump up there that basically takes the hot water and spins it around the building. It basically goes through a series of baseboard hot water heaters that are in the house, radiators. You know, I'm from Philadelphia. We had radiators, and it's basically that, but they're baseboard radiators. And each room has one or two of them in each room, and they're controlled by manifolds with thermostats. So it basically goes up to the manifold and says, is this room thermostat calling for heat in that room, and then it will deliver that heat to that room if it's needed, is basically how it works. So it's a fairly simple system, fairly inexpensive in relation to in-floor heating. A lot of people said, well, you know, why didn't you get in-floor heating? We were offered, because this is a high-profile case study project, we were offered for free from the manufacturer to put in-floor heating, and it was sort of at an early stage in the process, and my wife and I, you know, kind of thought about it, and we asked the manufacturer, so how much would this cost? And they said, well, the tubes alone would be somewhere in the neighborhood of $24,000, and you know, we thought, wow, and it would be nice if we could get that for free, but everybody can't get it for free. So it was like a real turning point in the, not turning point, but a defining point in our process of thinking about it. Like, we wanted to make this house that anybody could build, anybody could live in, and so we, you know, we thought about it. We learned later is that because of the high thermal mass in these radiant floors, it doesn't actually work well for our coastal environments. It works great in like Minnesota, where you have to, you know, it's -5 outside, and you have to maintain the indoor temperature throughout like extended periods. But for our situation, what happens, in which you guys all know, in the coastal zone, it's foggy in the morning. In the afternoon, or even by 10 o'clock in the morning or noon, the sun comes out and it gets really warm. Our friends who installed this kind of thermal floor heating systems found that they had to start opening the windows because the high thermal mass in their floors wasn't cooling down quick enough, and it was making the buildings uncomfortable. So these radiant baseboard heaters in our coastal zone work really well because they heat up very quickly and they cool down very quickly. And we found it works really well. So again, same idea. When we're on vacation, we can just, you know, turn it off. A very simple system. This is as complex as my whole building gets. Basically, a pump, a ballast to keep from, you know, what they call pipe banging in there, and that's a couple of temperature gauges. That's basically the extent of it. Same thing that we talked about before. Once a year, I drain the system. Change the anode rod every 5 years, and you know, pretty maintenance free. The interesting thing that has happened over time is that the temperature in our area has changed a bit. They built 4 degrees into the design of the building, where the outside temperature could get 4 degrees hotter than the design temperature of the building, and still be okay. And what we were finding was, for the first 8 years that the building was in operation, we never had a problem with the building overheated, like literally not one day. And because of the insulation on the roof and the other things that we did, it blocked the radiant heat, so it all worked well. But in the last 3 or 4 years, we found that the temperature in the building in the summertime actually got up to 78 degrees, somewhere in that neighborhood, and would not cool off as it should have. And I think that's what, you know, and I called one of the engineers, and they said, well, we've been breaking all kinds of temperature records, And we designed it for 4 degrees, and you've already broken through the 4 degrees. So it's getting hotter, and that's just the reality of the situation. So if I was to plan the building again, I would not use this radiant system. I wouldn't use a heating system, if you will. I would probably go to a heat pump, some version of a heat pump system, which we're going to talk about later, to replace this system. So just, in thinking about that going forward, with all of the smoke problems that we've had and other things, it would be nice to be in an environment that you can close all the windows and still feel comfortable that you're getting good fresh air into the building. So that is one of the changes I would make as a result of the change in climate that is happening in the building. But that's my heat pump hot water story. Nick, did I miss anything? Are there any questions
for Robert?
Yeah, please. Anything?
Nothing in chat yet.
Nothing in chat yet. All right, Nick, did I miss anything? Anything you wanted me to talk about while I'm down here?
No, and I'm going to cover the HVAC heat pump section while you go back to the office, and then you can cover heat pump water heaters in a little more detail, and we can get any last questions there.
That sounds great. All right, I'll see you guys up there.
Okay, thanks, Robert. Going to remove the spotlight on him. All right, and I jumped ahead to where we need to be here. Heat pumps. And we're going to start with a little video, but like Robert just said, HVAC heat pumps are the one thing he might do all over again. These are often called heat pumps for short, ductless mini splits, ducted mini splits, mini split heat pumps, a lot of words for it. Variable refrigerant flow, but they're basically reversible air conditioners. They provide heating and cooling using the air conditioner technology, but by reversing the flow of refrigerant in winter, they can also provide heating to the building. So let me just play this introductory video for you.
In the past, conventional electric heat pump systems were known for their poor efficiency and performance in cold weather temperatures. Today, advancements in modern variable speed heat pump and zoning technology gives everyone in the home year-round comfort, even in sub-zero temperatures. Here's how they work. Ultra-efficient variable speed heat pump systems consist of an indoor air handling unit and an outdoor condensing unit. The units are connected via 2 refrigerant lines. Working as a system, the units efficiently transfer the desired cooling or heating energy to each personalized comfort zone. In summer, air conditioning is produced when heat energy from inside a home is absorbed by the system's refrigerant and transferred to the outdoor air. In winter, the refrigerant cycle is reversed and the system extracts heat from the outdoor air and transfers it inside to heat the home. When compared to fossil fuel burning systems, modern variable speed heat pumps provide exceptional heating performance while being a greener, more environmentally friendly option. To achieve this, variable speed inverter compressors use up to 40% less energy than past conventional systems by modifying the compressor speed up or down as needed in order to maintain consistent, comfortable indoor temperatures, a feature conventional systems simply do not have. As an added benefit, some systems allow a single outdoor unit to control up to 8 indoor units for added comfort, efficiency, and styles within a home. Ductless indoor units circulate and filter the air already in your home, resulting in improved air quality with whisper-quiet operation. Today's revolutionary inverter compressor technology is an impressive advancement in residential heating and cooling. These smart systems regulate energy consumption, using only the precise amount of energy needed to keep a home comfortable, saving the homeowner money while reducing our carbon footprint.
Great. The thing that I love about that video is these 2 images. I don't know about you, but growing up, seeing that big cube of an air conditioner in my backyard, I thought that fan was moving air in the house. I had no idea, right? But what it really was doing was when you're cooling the house, it was expelling hot air. out to the outside of the house. It was removing heat from the indoor space. Think of it as a heat rejection system. And so in wintertime, like in the bottom picture, it's able to take the heat in the ambient air outside. There's enough, even down to really low outdoor temperatures. Use the compressor cycle to heat the refrigerant, heat the inside, and then take the cold spent refrigerant back to do it all over again. So that's how heat pumps can provide heating and cooling in one system. We've gotten used to putting a gas furnace in for heating and an air conditioner in for cooling, and halfway through the year switching from one to the other. And in retrospect, that was a more complicated system than we ever needed. These single heat pump systems can do both. They can do it efficiently. They can do it in a wide variety of temperatures. They're often simpler or less expensive to install. And as I'm going to show you, there's a wide variety of configurations. The high wall units were featured in that video, but they also make ceiling cassettes, ducted systems, floor mount radiator style systems. So I think you'll find that you can find a configuration that works for just about every project. And you can remove ducting as one of the headaches on your construction list if you so choose. Real quickly, the federal efficiency standards changed in 2023. We should all be aware of this already. But instead of measuring efficiency on SEER, EAR, and HSPF scales, they're now SEER 2, EAR 2, HSPF 2, indicating a different test method and slightly more stringent requirements. So make sure you're specifying and installing SEER 2, EAR 2, HSPF 2 equipment from now on. This guy here is no bodybuilder. He's Rick Chitwood. He's an HVAC legend in California, behind a lot of the code requirements in Title 24, a high performance mechanical contractor. And he's holding a ducted mini split heat pump unit, the indoor unit, in one hand. He's a little red, but you know, it's not that heavy. These things are designed to fit within drop ceilings, small spaces, and they connect via refrigerant lines to the outdoor units, just like the ductless high wall units do, as we showed you before. And the advantages of these, you don't need the separate furnace or gas lines or flue vent pipes. We're not creating combustion gases, so we don't need those penetrations through the roof anymore for flue vents. There's no combustion gases to dispose of or worry about. They're quieter than standard air conditioners. I see George's point that noise may be an issue. I would say only when compared to heating only, because heat pumps are, if anything, quieter than air conditioners. They're inverter driven and run low load a lot of the time. They tend to list decibel ratings between 40 and 55, which on the low end is like a efficient dishwasher. They're often suitcase style, space-saving footprints as well, like shown by Rick there, and can create utility bill savings. Of all the electrification end uses, it's HVAC where the biggest savings are, in my opinion, based on my modeling. Ducted mini splits. Yeah, this is what we're talking about. The prior video was ductless mini splits. Here's ducted mini splits, and they have the same inverter driven variable speed capability, but instead of distributing through that small unit single zone, it's got some duct system hooked up to it. Now, they're not capable typically of serving a whole big 5,000 square foot home. Ducted mini splits are meant to be more compact distribution systems, maybe serving 4 or 5 rooms, although they do make them up to 5 tons, which, as long as there are high static pressure units and able to overcome all that resistance of a big duct system, it can be possible. But in general, I see these installed multiple smaller tonnage ducted mini splits in a house. And a big reason for that is just getting ducts through the house is hard. And so ducted mini splits can be, okay, here's the bedroom zone, here's the living zone, here's the upstairs zone, and it gets around the issue of running ducts and chases all over the house. We did a survey of contractors, and what I often hear is heat pumps cost the same or less than the gas furnace split system. So we said, what if you're doing a 600 square foot addition? Can you quote me on a gas furnace like for like replacement and a heat pump? And you see the range of estimates for the gas system was 6 to 15,000. The range of estimates for the heat pump was 6 to 13,000. In this case, every contractor gave an equal or lower bid for the heat pump. And I think you'll hear that a lot, about the same. Now there's a bunch of packaged unit heat pumps available too. What we just showed you is called a split system, and that's where the mini split term comes from. These are packaged units where there's no separate outdoor unit. It's all contained in one through the wall unit. The picture on the right you might see in a hotel room or a nice apartment building, but it's not a PTAC, that's air conditioner with electric resistance heat. It's a PTHP heat pump that's capable of reversing. So you get more efficient delivery of heating than you would with the electric resistance option. The sleeker unit on the left is also a packaged heat pump. It's called Epica, EPHOCA, made by an Italian manufacturer. And it's got two 8-inch ports through the wall. Doesn't need a condensate drain. It atomizes the condensate and blows it out the ports. Pretty cool design. And I know Robert, who specializes, he's one of the most experienced guys in the state in terms of multifamily buildings, electrifying them. He's done a number of buildings with these Epica units to provide dwelling unit heating and cooling.
Yeah, they're fascinating because the opportunity to do something really different there is present. And their most sophisticated unit has a couple of key advantages. One, it has a MERV 13 filter in it, so that oftentimes these multifamily buildings for disadvantaged communities are right by a freeway. And so without a MERV 13 filter, that's a really, really dangerous situation, taking in all that pollution. So with a MERV 13 filter, and it also has an ERV in it, which basically takes the cool air that's going out and switches it with a heat exchanger for the hot air coming in. So it makes it much more efficient to run that unit at the same time that it's filtering that air. And that unit costs about $6,500 list. And to install the equivalent cassette style mini split system with packaged unit on the roof, I'm sorry, with a compressor on the roof, would be about $15,000 to install on average. So if I could put one of these in the main area and then one of them in the bedroom, for example, that would be a net savings for the project. And you get the bonus of filtered air and the ERV, the energy exchange, for free, basically. And you have to know with the split systems, there is a filter in the unit that basically, protects the moving parts within that unit, but it doesn't filter the air, if you will, in the same way that this MERV 13 filter is filtering the outside air coming in. The split systems don't have an outside air unit built into them, and we see this as a real advantage of this package terminal heat pump. It's a really innovative design, and we're advocating it for that reason. And again, it's built in the factory. It doesn't require a maintenance person to come and you know, hook it up properly. We find that up to 34% of the callbacks are because it wasn't installed properly. And this unit, like your refrigerator, will last forever because it's it's put together and tested in the factory and shipped out in the box, and it has a 10-year warranty on it. That, in our experience, saves a lot of time and aggravation in the field.
Thank you, Robert. And hot off the presses, we're always updating slides. The New York City funded a competition for window unit heat pumps. And this gradient design looks like it has a ton of potential. It fits out the double hung window. It's got little seals to make a nice air seal. And this company Gradient's going to install 10,000 of them for New York City Housing Authority. They're 120 volts. They're 3/4 ton, 9,000 BTUs, quite efficient. And the residents have been thrilled with them compared to those noisy wall air conditioner units that don't also heat, right? You've got these big boilers in the bottom of New York City apartment buildings that use radiators to heat, and they're a constant source of discomfort to all residents. Or maybe the ones right in the middle floor are happy and all the others are unhappy. So these are really exciting to see what we can do with existing multifamily buildings using those style heat pumps. But just to do a cutaway, what's happening behind the scenes is the outdoor unit is the one that's expelling that heat in cooling season, right? Harvesting that heat in heating season, connected with refrigerant lines. Just the size of a tennis ball is all you need to make that penetration to the indoor unit, whether it's ductless, ducted, or what have you. You can link multiple indoor units to a single outdoor unit. Manufacturers say often up to 8 indoor units fed by 1 outdoor unit. And these are where you unlock the most efficiency. They do make standard, what I call dumb heat pumps. They're on, they're off, they're single speed, and they're more similar to your air conditioners you grew up with. But these inverter-driven mini splits are what really unlocks the efficiency, because they can run at low load so much of the time, especially in California where our temperatures are quite benign. And that's when they run the most efficiently, and then just ramp up on those extreme days. Ceiling cassettes. Robert, there's a question if you could answer about the Epica.
Yes.
Ceiling cassettes are a nice alternative to the high wall unit. They're recessed like this really clean one-way ceiling cassette here. This four-way cassette that just came on screen sends conditioned air in all 4 directions. You do have to provide for condensate to drain out of these ceiling cassettes, but they're quite attractive and unobtrusive. The ducted mini splits are the other option, where if you don't want that high wall aesthetic, you can put that ducted mini split that Rick Chitwood was holding in some recessed ceiling somewhere and run ducts, including these really attractive linear ducts that some of my LA architects tend to like. And they're really efficient. For comparison, when my house was running a gas furnace split system still, and the ADU had its ductless mini split heat pump, I looked at the same period. This is May to September. So the weather was exactly the same. And the ductless mini split in the ADU used 570 kilowatts in summer of 2022, while the main house air conditioner used 1,460 kilowatt hours, plus whatever the gas was required for heating. So the virtue of small spaces and super efficient mini splits on display here. Robert, I'm going to let you show the slides for heat pump water heaters now.
Right, let's go.
I'm a little ahead of you in the normal flow of the slides.
No problem. Let me go back to those. And there we go. All right, you should be able to see that now, right?
If you just slideshow it, yeah,
Full screen. There we go.
beautiful.
All right. So going back to the electric heat pump hot water heaters, as you saw in my garage, that's the way they work. There's a couple of things to know, and somebody had mentioned sound, you know, that they make a noise, if you will. And so you really want to be careful about where you put them because they do a couple of things that are different. You can't just put them in the same closet that you had your gas-fired hot water tank, for example. You could, you know, potentially put them in that that closet, but you would want to get a fully louvered door because again, it needs the air from the room to really work efficiently. If you close it up into a room, it'll turn that room into a refrigerator is essentially what will happen. And it does make some noise. So you just, you know, if that would be bothersome to have it next to your bedroom, you know, you might want to think about putting it someplace else. Again, the garage is a very, very good place for it. But generally, it's less expensive to install, operate, and maintain than the gas-fired equivalent. It's 3 times more efficient than tankless, as we mentioned. It has the demand response timer that we talked about, so it can shut itself down on vacation or from the 4 to 9 period. This next bullet point is really game-changing. They all came out as 240-volt units. And it was a problem because you had to get an electrician in to run a, you know, this and that and the other thing. And now they are coming out with 120-volt retrofit units, and we're recommending them for new construction and everything. So it's really the way to go because you don't need the 4,500-watt resistance heater in there anyway. We don't recommend that, and it creates a huge spike that would penetrate that solar envelope that we talked about before, that blue, you know, the generation thing that we saw in the graph earlier. It would break through that and cause non-bypassable charges. And so we'd rather have it running at 500 watts throughout the course of, you know, an afternoon or whatever. And again, it stores 50 gallons of fresh drinking water. And we see that as a huge advantage over tankless. In that when there's an earthquake, we know what happens. They cut the water. And for every housing unit to have 50 gallons of fresh drinking water stored in that unit versus a couple of ounces that you really can't access in a tankless hot water heater. It's really important to do that. I mentioned before, it dehumidifies in cool spaces like garages and surrounding spaces. In, you know, houses in Palm Springs, they put them in the main house for that purpose. But again, it requires careful placement for air volume and sound. The sound that it makes is about 44 decibels, and that's about the sound of a very high quality dishwasher that's operating. So there is a sort of low muffled, you know, sound to it. And you have to be careful with the placement. Nick, this is your slide, I believe, right? Clayton Homes?
Another new slide. Yeah.
You want to
This
talk about
one, this is a factory built builder, Clayton Homes, and they have a platform called eBuilt, I think it's called, that's all electric. And so they just quietly installed 24,000 heat pump water heaters in under a year. That's the kind of volume they have. So these are zero energy ready homes, and they qualify for DOE $5,000 rebates or tax credits. I forget what it is. So they've had real success with it.
Beautiful.
And by the way, my rice came out great.
Nice.
Yeah.
Beautiful. 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 And what was the time on the boiling water?
Oh, I didn't time it, but
What?
minute and a half maybe.
Yeah, it's crazy fast. It's
Yeah.
especially with the 240 units, 240-volt units. It's crazy, crazy fast. Okay. So location. As I mentioned before, a fully louvered door is required. You might even undercut the bottom of the door to allow that hot air or the cold air to get out and the hot air, you know, of the room to get in there. On this unit, obviously there is still the, you know, you would want to insulate the hot water pipe coming out of the unit. On both of these, we don't see that happening, but you definitely want to insulate those pipes coming out of there. And yeah. Again, we want to talk about using it in the middle of the day, charging it in the middle of the day, and thinking of it like a thermal battery. And Nick, you created some comparisons of these. You want to talk about that? Oh, I can't hear you. Is that me?
It's me. I'm sorry. Classic. I call them energy sippers because the first hour rating is the measure of how many gallons of hot water can you get out of a storage water heater, right? And so we're used to the gas ones being almost 70 gallons for a 40 and almost 90 gallons for a 50 because they recover fairly fast. They're about 30,000 BTUs that they can heat. Heat pump water heaters are lower than that. 4,000 BTUs. The one I have is 12,000 BTUs. So they're designed to store enough hot water to get you through that shower or back-to-back shower or whatever it is. And then they slowly replenish the hot water and ready for the next time you need it. I'm here to tell you this limitation, if you will, of heat pump water heaters has been way overblown. We don't need gas tankless water heaters with never-ending hot water in most homes. You might need it in a commercial restaurant, but we don't need it in homes. And I think we've falsely gotten used to the concept of never-ending hot water being a need. It isn't. And so by going to larger tanks, like the 65 and the 80 gallons, you can have that same first hour rating of the gas water heaters you're used to. So that's why we tend to recommend upsizing the tank so that there aren't disappointed people who were used to a 50-gallon gas, install a 50-gallon heat pump water heater, and a couple days a year run out of hot water.
Yeah, or increase the temperature, right? Which has the net effect of the same thing. And then we had a comment from Jan who said contractors here seem to be charging a lot more for the installation than the unit itself. And we have found some gouging as well because it's new technology and they're not familiar with it and they try to charge you for the learning curve. And that's why finding the right contractors and then qualifying those contractors in advance, asking them how many they've installed in the past. And normally there was an upcharge in my experience because you had to install the 240 line. So you had to find somebody who both was an electrician and a plumber, and they by natural trade, are more expensive. But with the new 120 volt units, you can just find a plumber and you don't need somebody who's a plumber and electrician and just plug the thing into the wall. There's usually an outlet within, an arm's length.
But in fairness to the plumbing industry, putting in a heat pump water heater isn't a standard takeout gas put in electric, as Robert said. You're going to need a new door on a closet. The inlet and outlet may be in a different place. So it's fair, I think, to charge more to retrofit to a heat pump water heater the first time. Just, ask around and make sure they've installed some so it's not the fear factor, it's the real added work you're paying for.
Yeah. And then there's a comment by Joshua for retrofit of an existing gas water heater, any best practices of existing water heaters in central closet with gas, electric, FAU to be replaced and removed as well in home.
He wants the closet back. I get it. Yeah. Well, the garage is a perfect place where Robert has his, where I have mine for the ADU.
Yeah. If the garage is kind of a distance away and detached, it becomes it's a little bit sorry, go ahead.
Sorry, Josh, where do you live?
In Southern California, Altadena.
Altadena. So is it possible, and this is what Nick did as well, I shouldn't even, I'd be careful, but to put a pad right next to your house and put a little, aluminum
Closet. Yeah.
closet.
Yeah, that's what I was wondering, is if there's that's probably what the homeowner will end up, we're considering, but
Yeah.
so,
Your
sweet.
daughter needs you right now, Jim.
Yeah, I know.
Yeah.
Sorry.
No, enjoy that moment. Enjoy that moment. Yeah. There
It
will
doesn't
be a
last
time
long.
when they are the opposite of that.
Yeah.
Exterior closets work great
Yeah.
in
They
Southern
do. Okay,
California,
that's what I guess.
Northern
I guess that should
California.
have been my question: is that are
Mhm.
exterior closets acceptable?
But
Yes.
they
For
need a
those
lot of
units.
airflow, not just the standard, like flimsy door with a small grate. You need a lot of airflow. So maybe a fully louvered door. The
Yeah.
resistance element will kick in on cold days. That's okay. It's not going to run at 300% efficiency on the coldest day of the year, but overall, it's going to do just fine, you know?
Yep. Agreed. Okay. So and so you actually modeled this out with your actual
This isn't
data.
modeled, this is actual.
Actual
Yeah.
data.
This
Yeah.
is measured in the ADU, 1 kilowatt hour a day for 2 people.
Nothing.
Yeah.
Yep. All right. So I wanted to talk about the differences in designing these things for multifamily specifically, because I have a lot of experience in this, and I've seen again, I've audited dozens and dozens of existing buildings, and then help these developers with the designs for the future. So what we generally see in multifamily buildings is what you see on the left. And there's generally 2 gas-fired boilers on the roof that go to tanks. So then they store the hot water, and then it runs in a recirculation loop around the building. That's generally what you see in the centralized version. There's, it's listed as outdoor heat pumps, in this particular application, but most of the time it's gas. And they've even still carved out an exception for gas for multifamily buildings to do this thing, and it's still a nightmare. So if you have any experience with this at all, when they initiate the building, they move the tenants in. There's always one tenant at the very end of the line who says, "I'm not getting enough hot water." And what happens, you guys can guess what happens. What do they do to mitigate the problem? They turn up the temperature, right? And you've just blown any energy efficiency out of the woodwork that you were planning for as a result of that. And then the loop then is continuously running with this hot water that can equate to 100% of the other, that is, the recirculation load can be as large as the load of people using that hot water for showers and everything else like that. So it's an incredible waste to have that recirculation loop running like that. And most of the time, in my experience, they don't take the time to actually use the balancing valves properly to run that recirculation loop optimally, and they just choose to increase the temperature coming out of the hot water boilers. So that's an incredible waste, and the pumping energy as well is significant in that exercise. And as a result of the strain on the system, the warranties for that centralized system are like 6 months generally on the equipment. So that's, sort of worst case scenario. Still happens a lot because the trade-off is to create a hot water closet, which uses square footage of the building. And developers don't like to use square footage for anything other than something that they can rent or sell. So in the shared one in the middle, there's a chase that's created through the center of the building, which they can then feed like 6 or 8 units going straight up vertically, and use 2 heat pump hot water heaters in the garage area that would basically feed those units. So the advantage of that is that the units cost less. You don't have to have, with the first situation, you have to have a maintenance person 24 hours ready to fix those systems, because if those hot water boilers go down, the whole building goes down. And if you want to get people really pissed off in an apartment building or a condo, you know, turn off their hot water is essentially the answer to that question. In this situation, only a select number of those people would, you know, have a problem. And so it limits the downside risk, if you will, of it to 6 or 8 units. And the recirculation loop is much, much tighter. So it's easier to manage and control that recirculation loop. The warranty period for those tanks would be 3 years under that circumstance, because you're sharing the hot water tanks at the bottom with multiple units. The situation on the right is a unit serviced by one tank. So if you pair one tank with one unit, the warranty goes from three years to 10 years. And my job, you know, I'm helping developers with sustainability and cost containment. And this is a huge one because I want to get them out of the hot water business. The hot water business is not a good business to be in if you're the owner of the building. It hurts your net operating income significantly. So in this particular diagram, I would have gotten from a design standpoint, gotten the hot water tank closer to the loads. I think there's a way to do that in the diagram, but we don't have to talk about that now. Even with the longer loads, you've got one unit, you have to allocate space to it. So again, developers don't like doing that, but you have to plan for that at the very, very earliest stages and say, that cold air that I'm creating, could it actually be a benefit to the unit if I ducted it inside in the summertime? Could the maintenance people or the occupants actually throw a little duct lever and have that cool air coming in to help cool the space during the summer months? That's an opportunity that could be had in that scenario. But again, looking at it, there's no way for a lot of people to get, you know, sort of angry with you because there's no hot water, because it's one unit per one apartment per unit. And if the unit goes down, you basically just very quickly call the maintenance person and say, hey, can you replace the unit under warranty? And they have, you know, some in stock that they can just replace very, very easily and very quickly. So those are the 3 scenarios that we want to look at when we're doing multifamily, and think about the first cost and the long-term operations and maintenance costs of these things, because they're significant over time that we're finding. And the next few slides are basically telling you everything that I just told you, and so you have them in the slide deck. And by the way, this door is not the door you see in the slide is not a fully levered door, and we don't actually recommend those 2 smaller grates because the more airflow you have, the more efficient that unit will run. Okay, now to heat pump clothes dryers, and Nick again was my inspiration for this. We recently bought one and can't believe how good it is. The previous unit we had was resistance, you know, just normal electric resistance, and it worked just fine generally, but it was peaking at like 3,000 kilowatts, like, you know, just an enormous amount of energy that broke through that solar, you know, ceiling that we talked about. You know, when the sun was fully out in the sky, it was still, you know, very close, if not breaking through that ceiling. And the new clothes dryer runs at about 500 watts. So not a big deal at all. And the clothes come out beautifully. As Nick pointed out to me earlier, it doesn't have as much wear and tear on the clothes. So it's much more, you know, from a long-term standpoint, it's just, you know, easier on the clothes. What's
your cycle time, Robert?
My cycle time is longer than the other one, but it's not significant. So it went from like 45 minutes maybe to an hour and 15.
Yeah,
Sorry.
that's about where we are.
Yeah. And we did get the two, because we already had the plug there. We got the larger, I think it's 7.4 cubic
Okay.
drum or something like that. So we can do bedding and whatnot in it. But it works so well. And we closed off the hole for the duct for the vent. And it was full of, lint, which could have caused a fire and all that kind of stuff. Right? Well, we cleaned it out. We put some insulation in there, and I put some tin tape over the plug. I can't believe what a difference that has made in the temperature of that. That back room always used to be chilly, kind of cold and damp in there, and it was from that flue, essentially. So by cutting that thing off, the whole building is actually more comfortable. So it's really nice. You had a great story about replacing yours, though. I think it's worth telling.
Okay.
Why you replaced it and how you replaced it.
Yeah. Remember COVID 2020? I couldn't find a contractor to fix my gas dryer when the drum cracked. And that sprung me into action. Our dryer is in an interior closet, much like we were just talking about for Josh's question, right by my daughter's bedroom door. And the vent goes out through the crawl space by her outside window. And so I thought, gosh, if this drum is cracked, could we have combustion byproducts, as a risk inside the house near her room or outside the house near her window as a result? So, forget it. I'm just going to put in that heat pump dryer I've been reading about.
That's awesome.
So I got a Mealy. They told me I couldn't stack it on top of the LG. I did. They make universal stacking kits. Shown here is the paired set that we got for the ADU because we liked it so much. And yeah, it's just been nothing but trouble-free. There's an extra filter you have to vacuum once every few weeks to keep the coils clean. But other than that, I had no trouble training the ADU residents to use it. And look how efficient it is.
Yeah.
Like 1.5 kilowatt hours a load, no gas.
Beautiful.
Mm-hmm.
Yeah, well done. Well done. And this is an interesting story. I had a client recently wanting to move over to the pool heater. And I have another client who installed one and is very happy with it. So again, pool pump heat, hot water heating is easily done by a heat pump. This 120,000 BTU model costs about $4,000. Comparable gas models are between $1,000 and $2,000. Run year-round, this unit is estimated to save $5,000 in the first year, or 64% in the LA climate. It would run 9 hours on the coldest day of the year and receive a payback within 1 year. And my client still says, that the client that installed it still says it runs almost continuously, but they have it under the solar, window, so it reduces the energy load, but it still uses a lot. And so I had a new client, and I said to this old client, I said, can you insulate the walls of the pool before they gunite the thing? And he said, let me ask. And the pool installer refused to do it. And, for whatever reason, they couldn't put polyiso, in the pool. I don't know why you couldn't. But as a result of that, 54-degree ground, temperature is infiltrating this pool that they want to keep at 85 degrees all the time. So it's a continual battle without insulation. I don't know why you couldn't put insulation in there. It's one of these things that I'm giving a lot of thought to, because the second person who came to me and said they wanted to do that, again, their pool person didn't want to insulate the pool, and they weren't convinced that this would work to try to keep the temperatures at 85 degrees on and on. But if you insulated the pool with 4 inches of polyiso, I don't think it would be a problem at all. So it's one of these things I'm a little bit in a battle with the pool people on. So anybody who has information on how to insulate a pool would love to hear about it. anybody who's had the experience of this, would love to hear about it. But we just wanted to, talk about all uses, and this is definitively one. I went to the Builder Show a couple of years ago, and there's a whole area in there with fireplaces in it, and they had flues that went up, but they actually didn't evacuate the conference area. They went up into the top of the building, and I said, how is that possible? They said, well, no, we got an exception to the code. But there was like 40 or 50 gas fireplaces going on all at the same time in the conference hall. And I thought that's insane. So anyway, I moved away from that area, and I found this other fireplace in like a deck area. And then I put my hand up to it, and it surprised everybody was putting their hand up because it looked so realistic. There it is in action. But this is not a heat source. It's actually, just LED lights and water vapor that can create that effect. So you don't actually need an actual burning. And if you want the heat, you can get resistance heaters below it to create sort of a, outdoor fireplace kind of feeling to it. So it's all doable with all electric. It's less expensive, and it won't negatively impact your Title 24 from a modeling standpoint as well.
Yeah, nothing to do with it.
Okay. And Nick, you want to talk about your ERV?
Yeah, and this isn't a required technology for an all-electric home, but it's a nice upgrade. Robert talked about how the Epica packaged heat pumps have a built-in recovery ventilator. And what it's doing is it's tempering the fresh air coming into the house using the conditioned air you've already paid to condition. It works in both winter and summer to save on the heating and cooling energy use that you have to pay for in order to condition that outside air. So it ends up resulting in a sizable compliance credit in the energy code. So this is one of those things that can really move the needle if someone forgets to do something or installs the wrong HVAC system. This is one of those get out of jail free cards that can sometimes solve that problem. But what I love about it is because of these ducts for the fresh air and the exhaust air, you can distribute it better throughout the home. And I did it during COVID when my daughter in this very office had 3 friends over in a COVID classroom. And I was monitoring the air quality. And of course, they were getting tired at 2 o'clock because the CO2 was accumulating in that room. So putting a duct from the HRV completely fixed that problem. Of course, they were teenagers. They still got tired in the afternoon. But that's what recovery ventilators are great for, improving the distribution of fresh air and some energy savings.
Super. And Josh just posted his link for the Eco Smart Fire. Lots of options and beautiful. If somebody wants fire and heat, thank you, Josh, for that. That's fantastic.
And Jan, yeah, this is a separate system. This is a dedicated outdoor air system, or DOAS, that is not part of your HVAC system. Although the ducts can be integrated with the ducts of a central air system, it's not the best practice to do that because these are typically moving 100, 200 CFM of air, and your HVAC system is moving 1,500, 2,000 CFM of air. So you don't get the good distribution of air by putting 100 CFM in a duct system that's designed for 10 times that. So yeah, this is something you could retrofit. And in fact, I did that for my house.
Yep. And you want to talk about the small duct system that you actually put in?
Yeah, I ran little 4-inch flex ducts to distribute it throughout the house. So it was pretty easy.
Yeah.
Yeah.
And then Jan wanted to know how much something like that cost.
The units are $1,000 to $2,000, maybe even a little less, but the installation's going to double that. So maybe more, because there's a lot of work to hang it, run the power up to the place and run the ducts around.
Yeah.
Of course, in new construction, it can be installed at much lower cost.
And then how often do you change the filter in there?
Every 3 to 6 months, so it needs to be accessible.
And is it the equivalent of a MERV 13 filter, or what is the filtering?
They come with standard MERV 6 filters, but
6.
you can upgrade to MERV 13, and that's what California code requires.
Right. And there's no static pressure problem with that?
Well, it changes things, but you can adjust most of them allow you to adjust the supply in the exhaust fan to get them into balance.
Right.
So you can overcome that.
Great. Okay. Very helpful.
Mm.
Thanks. Great conversation. All right. Living with induction, cooking.
We did that already?
Yeah. We're all through there.
So let me just cover energy modeling now that we've got all the technologies covered.
Yeah, you know what, Nick, did you cover this slide? Because the question about ducted versus ductless, I think I can't remember.
I took that slide out in the interest of time.
Oh,
Yeah.
you did. Okay.
Yeah.
All right. All right.
We've got 20 minutes left. So real quick, I just want you to know that the energy code encourages all electric more than ever before. Heat pumps prescriptive standard, either water heating or HVAC. Source EDR metric favors the electric systems. The gas systems have to be electric ready, so that bumps up the cost compared to electric equivalent systems. And then there's some carrots, like the variable capacity heat pump credit that can allow you to save in other areas of your design if you put in a qualifying mini split heat pump, either ductless or ducted. And on the screen here is a new feature that I'm hoping they unlock soon that will allow even more heat pumps to qualify for compliance credit. Look at the performance of heat pumps compared to gas furnaces in the energy code now. It wasn't like this 2 code cycles ago. In fact, they told Robert and others, you can't meet Title 24 with a heat pump at times, or with the heat pump water heaters. That's changed. And so now you can get 5% average efficiency credit for a simple central heat pump, 17% on average for a variable capacity heat pump, and even more on the source metric. But as we talk to people about heat pumps, whether it's contractors or if you're a professional, if it's a client, we need to talk to them about some of these things differently. First of all, it's not a jet engine on or off space conditioning system anymore we're talking about. It's running low load a lot of the time, maintaining temperature. So the comfort's different. The comfort is better, I would argue, with heat pumps, although you'll hear people argue the opposite point, generally based on experience 20 or 30 years ago with prior generation heat pumps. Realize that just like the heat pump water heaters that come with backup electric resistance elements for when they're falling behind, some heat pumps for HVAC come with these heat strips, and they can erase your energy savings if you're not careful. Most climate zones in California with good building envelopes shouldn't need backup resistance heat for HVAC at all anyway. We talked about the heat pump clothes dryers. They're going to cost more upfront, but there's some small energy savings, and that gentle treatment of the clothes and not needing the exhaust duct are the key selling points, I think. Not needing to run gas there, health and safety as well. And then the water heaters, as Robert does and as I do, run it in heat pump only mode. And only if you find that's not enough, turn on the resistance element function. Upsize the tank if you're concerned about running out of hot water. You can set it to run not during peak period when rates are highest. So that's a really nice feature to your pocketbook and the grid in California, which is why utilities like PG&E have incentives to have heat pump water heaters hooked up with communication modules so that the grid operator can say, hey, we're struggling a little here. Please don't heat up hot water for the next 2 hours. So we need to overcome the objection for space required and recovery rate. But I think we gave you talking points on that. The compliance credit on heat pump water heaters is solid. An average 8% for a generic one, 10% for a NEA Tier 3 one, which they all are these days. And if you tell the software, I'm going to use this make and this model, boy, that's when you maximize your compliance credit. And you can see it differs by climate zone, but it's pretty solid, those orange bars across all 16 climate zones. And the boost is really good when you go to source EDR for that maker model specific. Now, are you going to save a ton on your utility bills going to a heat pump water heater? I say, honestly, no. It's kind of a push, as you see from this analysis here, between 1 and 8% difference from a gas tankless. The savings are going to be in the HVAC. The savings are going to be when you have solar panels. So much of the operating kilowatt hours you're producing yourself. But just going from gas to electric water heating, call it a push. And here's the compliance credit for the heat recovery ventilators we showed you a minute ago. 8% average efficiency EDR, although not so much in mild climate zones like where Santa Barbara Ventura is climate zone 6. You get bigger savings in more extreme climate zones. So add it all up, I just want you to know the energy code compliance picture. If you go from mixed fuel, same features, to all electric with variable capacity heat pump, a heat pump water heater, you're going to find a much easier path to energy code compliance. And it wasn't like that just 5-6 years ago. Here's a chart saying the same thing. So if you're getting pushback from your energy consultant on all electric designs, are you using the current software? Isn't all electric roughly equal to or better than gas now? Did you use the variable capacity heat pump credit? Did you specify a specific heat pump water heater? And if all those fail, well, how far away are we? And can you show me the summary of energy use by end use? Let's see if we can drill down into where the compliance deficit's coming from and ask them, what could we do to close the compliance gap? Robert, you want to bring it home? Maybe he stepped away. But this is already happening all over Southern California. Progressive home builders like City Ventures, Meritage. Oh, you back, Robert?
I am sorry.
Okay.
I just had muted because I was typing.
Okay.
Yeah. So yeah, home builders are already onto this, and they understand, you know, and again, just not having two utilities, it makes a huge difference. And so we've helped developers save millions of dollars by, you know, them not having to run the gas lines, because the most expensive trade on your site will be the gas plumbers, period. So installing those trenches, and we've heard there's an upcharge of like $10,000 to do any trenching to any of these buildings. So if you can eliminate that, that buys a lot of solar. And you can't put anything else in that gas. So you can't put the sewer in there. You couldn't put anything else in that gas line by code. That trench is only has to be dedicated just to gas. So you have the opportunity in doing that to use those resources differently. A buddy of mine works for National Core. He's the head of sustainability and development over there, and did incredible projects using the incentives of SOMA, Tech, California Energy Smart Homes, the BUILD program, LITEC, and MAHAP, and got this building down to $127 a square foot as a result, which is astounding in Southern California. But but they did it really so efficiently that the not only the first cost, but the operations and maintenance cost went from $134 to $175 a unit, to $13 to $17 per month per unit. And the savings applied to the rent added up to $160,000 per year that added to the revenue to the building owners. And so that made it much more feasible to really take care of these affordable housing developments in the way that they needed to take care of. So this is really a money equation at the end of the day, and doing the right thing and making, you know, cents, dollars and cents, is really the way to go. And they were able to, as a result of this system, to increase the rent that would normally go to the allocation of the utilities. And so again, that's how these buildings are actually better maintained over time, because they are economically viable to do so. They did a couple of things really right. They allocated the bulk of the roof to the solar, because too often what we see in the center of the roof are a bunch of HVAC units, and in the place where the solar should be, right? The roof is the engine of the building. I've been saying that for years and years and years, and we have to respect it that way. And so he put the HVAC units, connected them to the parapet walls, as you see there in the photo, and that left a lot more space for solar in the center of the unit. And Nick, how much time do we want to allocate the last 10 minutes for questions, or do you want me to go through this next section?
I think skip this last section and get to the summary. I'm sure Naomi has some sum up too.
Great.
Yeah.
Okay. So we've spent the last, you know, period of time with you guys, and we've really appreciated the robust conversation that we've had in the chat and in person. And any other questions that you have, please key them up for us, you know, as we get ready to close out the session by noon. But ideally, you know, what we want to start with is a building that heats and cools itself. It has a high performance envelope. It has good, well-sealed walls and ceilings, and high performance attics with continuous insulation. We've talked about the passive solar orientation and the shading, the high efficiency ductless mini splits, you know, the NEA rated heat pump hot water heaters, the heat pump clothes dryers, the induction cooktop, the recovery ventilator for fresh air, and the LED lighting. And we want to size the PV to the electricity use of the building and EV charging. So don't be afraid to put some extra panels up there. If you're doing it, in my experience, it's much less expensive to do it the first time than having somebody come out and add panels later. The technologies are ready. The systems are lower cost. 45% of greenhouse gas emissions are reduced versus dual fuel. It's healthier. Like, that actually should be our first bullet point, right? Because it's very expensive to get sick. Right? And so Title 24, and again, I'm privileged to work with one of the best modelers in the state. Nick Brown is terrific, and he has told you all the way through this program how Title 24 compliance is much, much easier as a result of the all-electric building profile. 7 efficiency EDR points and 19 source EDR points on average. Very compatible with EV panels, especially if you have the orientation of the panels correct, and you're thinking about the time of use window. And you're safe from natural gas hazards, right? Anybody who has ever Googled natural gas explosion, it's frightening to see those explosions, you know. And then we've packed the resources for you in all the rest of the sections. So the AMA study, the Building Decarbonization Coalition, the Rocky Mountain Institute, the Net Zero Nest is Nick and his family's website for the house renovation that they did. The Green ID House is our renovation. Energy Vanguard is a blogger that Nick loves. The Green Building Advisor is a resource that we both like. Architecture 2030 is a framework from which people are decarbonizing both residential and commercial buildings. And there's just a ton of resources that we stacked in there for you at the end. Everything that we really love is in there. So you have an opportunity to do a lot more research at the end of the process. But with that, I want to turn it back to the group and say, what additional questions do you have? And Naomi, is there anything else that you think we missed?
I almost wasn't unmuted there. I do have a couple of closing slides just to advertise some upcoming courses. If you have those, if not, I can share my screen. And then I'm also going to launch a poll that everyone can take throughout. Yep, that's great. So just the slides, so just knowing that AIA learning units are available for this course. So if you registered with your number, it will automatically be submitted. But if you have questions, feel free to email me. As we mentioned earlier, you will get the slides and recording in your mailbox soon, or your inbox, your email inbox, that is. And just advertising some upcoming 3C Ren courses that we have for the rest of this month. And visit 3cren.org/events for our full catalog of trainings. And I can turn it back to you guys to answer any last minute questions.
Fantastic. Thank you so much, Naomi.
Let me take Javier's.
Oh, yeah.
And Javier's a HERS rater, so thanks for joining us.
Yeah, good morning. I have a client that's basically having a problem. He the ADU it's a 300 square feet. It was designed with a gas tankless water heater. Okay. And in the middle of the construction, the owner said, no, I want all electric. So they went with all electric. Obviously the job it's not. They installed a electric water heater, but it's not a heat pump. It does not comply. So right now they're having an issue. So I wanted to know if you guys have any recommendations. The attic is very low. There's no room outside to do a heat pump. Is there any other ways that they might be able to, without destroying the ADU, doing that?
Well, you can share hot water with the main house. That's an option.
Okay.
Also, there's an exception in the energy code for ADUs. If this is the 2022 code and it's a new ADU, it is under 500 square feet, and they're allowed to use electric tankless water heaters prescriptively, as long as they qualify with the point of use distribution requirement.
All right. So it'll be the point of use.
And an electric tankless. That was put in the code for exactly this situation. Small ADU, not going to use that much hot water, hard to find 10 square feet to put the tank.
All right. And that's with the 2022 code?
Right.
And then they could also share hot water from the inside the home.
That's right. Although you can't share return air with the main house in an HVAC system, right? Because there's disease concerns there. You can share hot water.
All right. I'm going to have them look into the Title 2022, and then I'll check the share the water. Oh, that's excellent. Thank you. Appreciate that.
And Javier, if you do share the water, I've seen it done well, and I've seen it done not so well. Just in trenching, just make sure you insulate those pipes really, really well.
Good.
Yeah.
Yep.
All right. Thank you.
All right. Super. That's fantastic. And Nick, what was the date of our next class with the three?
I put it in there, October 9th, I think it is. Is that right, Naomi? Yeah.
Yep. Because that is one of the big issues, the panel size and how do we make my existing panel work? And we'll give examples all the way down to, a 60 and 80 amp panels that we've made work for people's cottages. So it's something you guys might want to tune into.
And Javier's, his client is going to be shocked when he realizes how much panel space he'll need for an electric tankless water heater, even for a small ADU. They take a ton of power.
A ton of power.
Yeah.
Yep. So that's the planning early. That's the thing we need to do. We all need to plan early because we can overcome these things. We could have designed something, right? A little nook for that tank hot water heater had we known earlier, right? But we get into that situation at the, past the 11th hour, that it makes it much more difficult and much more expensive to find the solutions.
What would you say to George, the cost to electrify a typical residence?
Let's see, go back.
30,000 maybe? I'm just, broad brush stroking this. And of course, you can find incentives for probably 20,000 of that right now. So your window is now, George.
Yeah.
But there's just so many unknowns in, what it's going to take to redo the HVAC and panel, but that's why those incentives are there for panels upgrades and heat pumps and heat pump water heaters. They want to encourage these early adopters to really drive scale on these products and drive down the costs and make it commonplace.
Yeah. And remember that to stage it out, or you have 10 years, these incentives are in place for 10 years. So stage them out so you maximize, your tax credits at the same time.
Yeah, and spread out the expenditures.
Yep.
There's also PACE financing, which can be linked to your property tax, passed to the next owner of the house. That's a way to do it. And who knows what else they'll come up with.
Great stuff.
12 o'clock on the dot.
We did it. Yay.
Perhaps that's why there are no more questions.
Right. This is normally a 4-hour class. We packed it in there.
Right.
All right. PACE financing is a property tax assessment on your building to take some of those funds. So it's a loan against your building, if you will, to do these kinds of retrofits.
Yeah. So if you were to sell the house, it would pass to them.
Right.
With whatever's left. So you got to use it responsibly, but it's an option.
Yep.
Right. Well, thank you to Nick and Robert for a great course. As you said, he packed so much information in there that made it so engaging. So thank you so much, everyone, for attending, and have a great rest of your afternoon.
Thanks, everyone. Thanks, Naomi. Pleasure working with you.